Instructions has a somewhat looser feel to it.
Yeah, it's got an almost improvisational tone. Oh. I bet everyone can hear me. The camera. One moment. Let's see if it turns on here. Oh, let's see. There we go. Sorry. Didn't have the camera on. Let's get everything set up. How's everyone doing this morning? How is everybody doing this morning? It is Thursday morning, 1 week into class. I saw that, and we're going to do some major stuff today. So today is a big day. What question? I know I need coffee too. Totally need some coffee. From our YouTube keeps recommending. It knows you want to watch it. It knows you have figured out that you like Stat to 1. This is BAS 320, but it's like, we got this. When it appeared, when I didn't appear this morning, I was like, oh no. I was like, oh my gosh. What happens if I don't appear? What happens if I have to do it? I guess I would turn off the camera, and I guess now it'd be so bad if you couldn't see me. Therefore, like, awesome stuff. So the assignment that was due last night, my neighbor like knocked on the wall yesterday, so I'm trying to talk quieter. Let's see if that works. We will cross our fingers. So hopefully, sorry. So if you hear me talking different tone, you're like, what's going on? I turned up the volume on myself. But tell me if you can't hear me at any point. Hopefully this all works. Just gotta, yeah. Anyways, there are 5 minutes the other day, twice. There we go. So let's hop over here. Let's look at a few things. I've got a bunch of stuff open right now. Yes. So there is a new assignment up. And let's talk about the new assignment real quick. Is everyone ready? Once again, these things all apply. But question 1, you must do. Question 6, or no, part 6, questions 2 through 5 only have to do 2. And now I considered making this due Friday, but I was like, wait, if I put it due on Friday, you don't get the weekend to do it. The new assignment is due on Sunday. And then next week, we're probably going to have stuff due on like, probably not, I don't know, maybe Tuesday, Thursday, and Sunday next week. And then we'll be looking at tests coming up. So exciting stuff. But how's everyone doing? Everyone's so quiet. Don't worry. You don't got to be quiet. How is everyone doing in the chat? How is everybody doing? Let's put here tips for assignment 2. Oh, tired. I know. You guys are doing excellent, though. Ben, you're killing me there. Ben, you're killing me. Oh, Sylvia, I was so close to doing it. Sylvia, I was like, when my alarm went off this morning, I was like so close to just hitting the snooze button. And I was like, what if I sleep for 20 more minutes? I was like, no, I gotta wake up. I gotta get ready. And so like, I was so close. Let's just move our class to 9 and we'll do a 40-minute class. I'll do a 5-minute break. We'll just do a 40-minute class. Let's not do that. Very tired here. Thank you, Austin. 20 points, everyone being here right now. 20 points for everyone being here right now. If you're here right now, you're getting 20 points. We're putting at 50 points max today. What do we call this? We used to call these Thinking Thursdays. And I need to make some graphics this weekend for some Thinking Thursdays. I don't have a Thinking Thursday graphic, but we need a Thinking Thursday graphic here. We need some Thinking Thursday. This is when we get our brain going. And feel free, if you want, we can make up our own things here. Like Miniterm made up Thinking Thursday. I love you, Miniterm. But we can always make up. No, Miniterm, I swear. You're awesome. Miniterm came up with Stat Nation. And Dennis and everyone has helped us out with the Discord. And once again, I've been hearing great things about the Discord. The idea that we have like a voice chat and people can go on there and talk to people and get help from people. I just think it's awesome. I'm really excited, and I just want to, you guys keep telling me how it's going. Keep telling me if the mini term, I mean, brain's not on yet. If the Discord is helping out, if it's making sense, if like you guys are learning a lot, because that's all I do. I just keep thinking Thursday hype. I like that, Jonathan, right there. Thank you, Jonathan. 20 points again, Jonathan. You're almost at the max. Oh my gosh. I like that. Get some hype going for Thinking Thursdays. So, once again, please email me when you're stuck. Do not worry if it's 11 p.m. Every email I get at 11 p.m. is like, Brian, I'm so sorry to email you at 11 p.m., but I'm stuck. And I'm like, no, don't be sorry. Because then I realize for every person who's sorry to email me at 11 p.m., there's a person who refuses to email me at 11 p.m. because they're like, I can't email them. It's 11 p.m. No, email me at any time. Anytime you're stuck. And we'll talk through it. We'll figure out what's going on. And sometimes after class, especially, there's usually a buildup of emails, like 40 to 50 emails. So, it'll take me a little while after class to respond. Hey, Streamlabs, thank you for showing up, Streamlabs. You got this. So, if you email me at like 9 a.m. and then I might email back at like 3 in the afternoon, because I'll usually do office hours to 1. But also, please remember, too, that I don't think we put that on here. A big thing, too, put this as 3. No, correct this. Is come to office hours. We'll fix this. So here's Brian's tips. Watch office. Come to or watch office hours. So, did anyone use any of the office hours videos to help them out? Let's see some people in the chat. Did anyone use any of the office hours videos to like get help with a question, to figure out a question, to know what's going on? Did anyone do that? There we go. We got Brad right there using it. Yes. I think, Brad, weren't you also helping other people? Like, weren't you on the Discord, like explaining how to do things, you and Dennis? Because from what I understand, like you guys, there we go. I love it. Well, I'm so glad that, and also, like timestamps. Something weird's been happening with the timestamps. It's letting me put the timestamps into the videos, but I have to wait like a day to put the timestamps in. Oh, hopefully, good. You guys can't hear me teaching live. 31 people. I need to send out some emails and be like, hey, if you're not showing up, you're not gonna know what's going on. So I've got here the video from yesterday. From a few days ago, from June 1st. Well, then we should have. Oh, because we're live right now. So this video has the timestamps. It's got the lecture right here. It's got the break. It's got this. It's got the BAS 4 homework 1. And then we go back to here. Here's coding basics. This one has timestamps too. And then we do this one. And what's weird is I put everything in this video. Maybe I could try reloading it. Wait. Oh, it's not showing the thing? I swear I put it in there. I'll try reloading it. I swear I did. Maybe I didn't. Maybe I clicked the wrong video. So hopefully there's not wrong timestamps. Way easier. Way easier. Way easier. Way less time. And yeah, and I'm really glad, Brad, that you're helping. I'm glad. I think it's the I at the start of your name, or the, yeah. So I'm really glad, Brad, that now I'm going to just laugh every time I think about how I just mispronounced your name. Sorry. It was like the worst, most awkward. Anyways, sorry, Brad, I miss seeing you. I miss having the office. So it's like, yeah, Brad took 201, and now I'm like, oh no, I just don't get to see people. How many assignments do we have? There's like, I think there's about 10 more, and I'll space it out. Oh no, your computer, no, fix that. So there's about 10 more assignments. We'll space them out. They're a lot shorter than the last one. All the upcoming assignments are a lot shorter. They'll probably take 30-40% of the time of the last one. This next assignment, I can complete this next assignment in 3 or 4 minutes. It's not a lot of work. If you know what you're doing for the next assignment, it's so little work. So the biggest thing is once again, be here watching live, because I looked over, I know, don't worry. It's if you know what you're doing. How long does the first one take me? If I were to start the first one from scratch, probably an hour. Probably an hour 20. Because there's just a lot. There's a lot to code. It probably took you guys like 5 to 10 hours. I think our rule is usually a 4th rule, but it's not that the next one should take you 30 minutes. If you understand the material, maybe it'll take you 30 minutes. Like if you understand it really well, next one will probably take 2 hours, but the rule is that we should do things in a fourth of the time you do it. That's what Charlie Quick taught me. He's like, when you take a test, multiply how long it takes you by 4, and then you kind of watch this. I'll give you $1 to. Oh man, 8.5 hours. That's good right there. Hopefully it was good learning. 12 hours. Hopefully it was good learning. So we gotta, what we gotta do? We could generate some random times for how long it took people to do it. Watch this. Random normal. Strain it 100 times with a mean of, let's say, 8 hours and a standard deviation of 2 hours. There's 100 randomly generated times. So, and then we can take these, we could go to this and go to round and round these to 2 decimal places so they don't look all crazy like. And then we could go here times, store these into times here like that, and we could make a histogram of them. Yeah, let's make a histogram of them real quick. So here's 100, can't spell times. Here's 100 randomly generated times, and these are just, but then we probably need some outliers. So what we could do is we could append to this vector. So let's turn this into a vector right here. Let's go here, and let's append to it. If you guys can tell, I love this. Where we can append random normal, and we're going to make like a bimodal distribution 30 times centered at 14 hours with standard deviation of 2. And now we've got it's really hard to tell what that second mode is. You can't even tell. We can make it more clear. Now there should be, ooh, can you not see it? It's like blending together. Wait, something's wrong here. Is this not generating times? Round, let me look at the times. Something's wrong. Random normal. Here, watch this. X. There's X. And let's save this as Y. What have I done? Oh, is it because this isn't open? Oh, it's because of that. There we go. And my brain has to slowly remember how to code. There's that. And then let's build this from scratch. Let's concatenate together X and Y. Their times has 200 times in it now. And we're going to put this back down to 30, not 300. Okay. And sure, make a histogram of it. It's a little hard to see where the bimodality is. It's doing it now because times has that, but let's do it back to 100. We should see the bimodality unless I'm going crazy. Yep. There's the bimodality of it. So maybe there was like a bimodal distribution, something like this right here. You can see the clear peak right here around 8, and you can see another clear peak over here about 100. We can make this really big right here. But so you can see around 8 there's a peak, and around, I think it was 14, I put a peak. And yeah, that's a bimodal distribution, and we were able to make one by making 2 normals and kind of blending them together. We can view them individually, all that good stuff right here. Just do that and make a histogram of one of them. Am I going mad? That's the way it looks. That is a normal curve. This is the where do you find the slides? This right here is a little bit off topic slides, but the slides are located under, let's go to modules, and all of the slides will be located right here. You can see the R coding basics, and here's today's slides right here. Speaking of today's slides, so once again, these are under modules. Let's hop back to the slides. Here we go with the slides right here. One of the issues I had on the assignment one that was the days of the week would be out of order. Is there a way to make R organize them correctly? Yeah, let me mention that real quick here, Alex. And Austin, 20 points, and Grant, 20 points. There you go. I think I answered. Yeah, awesome job. Connor, Brennan, Philip, 20 points. Everyone right there. Great job helping each other out. Putting days in the order. Let me show this real quick. Let me hop back over. And let me show something real quick right here. So we're not going to deal too much with dates. Don't worry, because I'll be doing this more in 474. 474 has already had their assignment over it. They go a lot quicker. And that's one of the good things about, I'm going to bring this over to here. One of the good things about taking 474 is you get the same material, but like more condensed. Like a lot of people in 474 say, wow, I can't believe I had trouble with this in BAS 320, but don't worry. That's everyone realizing like, wait a minute, it makes more sense now. And that's what we want. We want to like make sure you have a strong coding foundation. So it gets easier. That's the thing I'm trying to point out is like, I've had so many students who have never coded before. And then by the end of their time taking my classes, they're like, I can't believe how far I've come, how far I've learned, how much coding I've done. And that just makes me smile to, I don't know. I'm very, very proud of my students, and seeing them get the knowledge and learn how to code really makes me smile. It's just something I love. And I'm trying to remember, where is, give me 2 seconds here. I think, well, I know what I can do. Let me download your guys' assignment. Let me do that. I will show you how to handle dates a little bit because we haven't talked about that much, and it was pure bonus. Let me look at the chat. I had the chat down for a second. You're welcome, Grant. Oh, you were saying thank you, Deb. Austin, I won't steal your thank you. Let's go over here to the assignments. Let me grab the R basics. But let me say this. The first assignment has historically been one, like last semester when I wasn't teaching, what did I do? Last semester when I was not teaching BAS 320, I saw students pretty much scared to death. I saw students like, I can't do this, I'm going to fail. And I immediately went to the BAS instructors and I was like, your students are really freaking out. They're really, 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 because I've seen it and they should know it, that this assignment that we've created is one that really is a tough one. And it's a long assignment. And I'm so proud of everyone who worked it because, we do have drops. Don't worry if your grade's a little bit low. I put some extra bonus across it to help out. And then I have the grader grading it a little bit nicely. So I have them grading it. There we go. Got to load up. I have them grading it a little nice. So I told them, put it this way, there's a lot of opportunities. Brendan, you're good. The first time made me worry about the rest. No, Ben, don't worry. Wait, Andrew, if you're in here, Andrew, we need your advice. He's in 474 now. He's our 320 alumni. And he, remember Andrew's been in here and he was like, don't worry, it gets easier. I would say it literally drops from like a level 8 difficulty to like a level 5 to like a level 3 by the end if you're following along. Like everything will keep building. This class is one of those huge building classes. Don't worry if you feel like you've missed a building block, but it's like there's so many opportunities to keep reviewing what you're doing. And by the end, you'll be like, wait a minute, this is the same thing. And just to show you now, I'm going to give you some confidence. Ready? Watch this. Brian is going to make a linear model. Watch this. Here we go. So here, Brian is going to make a linear model. And so Brian's going to go here. He's going to pull up some data. This is just confidence building right now. So I'm going to go here. I'm going to go to M, which stands for model. We're just going to call model. We're going to save into it a linear model of height, tilde weight, comma data equals, survey 10. Now we've saved our linear model. Can anyone tell me for 20 points how to get a summary of my linear model? Can anyone tell me how to get a summary of my linear model? How will I get a summary for 20 points in my linear model? How can I do that? You got it right there, Brennan. You're totally right. You got it. Can anyone tell me there's a summary of my linear model? Can anyone how to tell me to see my residuals for my model? 20 points, everyone, giving those answers. Thank you guys for waking up. How can I get my residuals for my model? How would I get my residuals for my model? Any idea on that? 20 points? I'm putting it to 80 points today. You can get up to 80 points because I keep throwing out 20-point bundles. Any idea on the residuals? You got it. Residuals. There's all the residuals for my model. How could I make predictions with my model? Any idea how to make predictions? Guess what? Predict. There's predictions for the model. What if I want to see the actual Y values in my model? This one might seem complicated, but the actual Y values are the heights. So I could actually find the residuals by doing the actual minus the predicteds. So if you look at this right here, see this right here, this 16898? That's the residual. Because what is a residual? Residuals are actual minus predicted. So if you notice right here, we're showing things you maybe remember in regression. If you took my class, I'd tell you residual wrap. Residual equals actual minus predicted. Residual, actual, predicted, residual wrap. And learning this right here is very important, but you can do it in code now. But you don't have to do this because this right here, it might say false. I'm worried it's going to say false because I'll fix it if it does. Oh, it equals. Wow. It's saying false because of the rounding, I believe. And that's what I thought it would do. So I'm going to go here to round to 2 decimals. I'm going to go here to round to 2 decimals. There we go. So this is the exact same formula. This right here is the exact same thing as this. It's just a rounding thing, like it's carrying more digits or carrying less digits. But it was mad at me. Was there any trues in there previously before I rounded? Not a single true because it's carrying more digits on one of them. What is the residual? Right here. A residual is an actual minus predicted. We'll be talking about that a lot next week. A residual, here, watch this. I'll show you visually what a residual is. Visually, a residual. So let's go here. Visualize model. Take one guess, 20 points. What am I going to put in my visualize model to visualize it? Actually, the code's giving a hint. If you look at above it, what will I put in my visualized model? Oh, what is the... So the residual function, nice job, Brennan, right there, 20 points. Great job. And Nicholas and Alex, great job. So what the residual function does is it tells you this value right here. And actually, let me show it. It's calculating for you. Got to go over to Word. Where's my Word at? The residual function is calculating for you this distance right here. Space pen is back. The residual function is calculating for you this distance right here. So the residual is the actual minus the predicted. I can't spell predicted. Predicted. That's right? My brain turned off. This point right here, its residual has to be negative. This is the negative residual zone. These are all 0 on the line. And this is the positive residual zone. So a residual is just how much the model misses by. So you can see things that have big residuals, like that point that's behind. Oh, no longer behind me. It was behind me before. This point, these points right here have big residuals. But you can see the points with big residuals, either positive or negative. And this is a lot what we'll be doing. So there's coding in this class. We get you primed up on the coding, and then we get you understanding the theory. But does this make sense right here? How's everyone feeling on this right here? Please tell me if I'm too loud. I know I'm talking quieter, but I've turned my volume up, and I'm watching the meter here. Please tell me if I like peak, or if you're like, Brian, you're way too loud now, because I've now turned my volume up a good bit. So it's how far off. That's a good way to, how far off was our prediction from what little loud? How's that right there? There we go. I've turned down just a bit, so hopefully this is good right here. But yeah, tell me too loud, too quiet, and I can fix things on the fly. I've got things. So thank you, Alex. 20 points, Alex. Yeah, looks a lot like Stats 201. You're welcome, Alex. Glad to help out. Perfect. We're going to keep it this perfect right here. Perfect is good. Now I've got like limiters and I've got all these things. Sounds perfect. Thank you so much. And thank you, like Haslam College of Business has invested in this. Like if you look at my microphone, it's not like your usual microphone. It's a very good microphone. So I'm really lucky that they're like, we're going to get you all the equipment you asked for. And I was like, okay, cool. And I was like, can I have this? And they're like, yes, you can. And I was like, awesome. But we've made a lot of good use of it. Like we've got Stream Decks and everything. Woo, Stream Decks. So, and then I showed you, it's my favorite thing. It's my this thing right here. This thing is so cool.
This is my favorite toy.
Let's go back. They want me to say one last thing. For anyone thinking that this is just, we gotta do, is that a Shure mic? It's Shure. Total Shure. No G Fuel. We need some G Fuel in the background. We'll play Carpe after this. So if anyone was like, what this thing actually does, this thing right here, you're seeing that, you gonna do it? There we go. So I can control the volume on everything that's coming in through the computer. But one of the most important things, which we should go to the mic, is it's actually like it's making my keep the voice changer. I need to mess around with the voice changer more, and I color coded it and set it all up. Like you can see my color coding scheme, but this right here is one of the most important things. Like, so I can't talk too loud and I can't talk too quiet. It'll actually raise and lower my voice. So when I'm doing stuff, it'll, now you're missing your specs in the description. Oh, I should put that in maybe, Alex. That'd be pretty cool. But this right here makes sure that like everything sounds good in my audio. Like I've gone through and made all these adjustments so that way my audio sounds very, very clear, very easy to understand me, because I think, you know, the audio for the stream is probably one of the most important parts. So good stuff right here. And thank you. Haslam especially has supported this, especially people like Mark Collins, Dwight, Jason Campbell, like Dwight Campbell, Jason Greenway. What am I doing? My brain is broken right now. Yeah, I watched tutorials on how to set it up and it wasn't so bad. Lots of streaming tutorials. And so this thing's really cool, really nice. And I'm really glad I have this piece of tech making our audio sound even better. That's totally a podcast thing. And actually one of the people I work with got a podcast thing and he's using that. Let's do it between transition screens. You ready? Let's crab right back. Here we go. We are back. Are you ready to learn how to do loops and conditionals? This is pretty big right here. Loops and conditionals. Has anybody, like random right there, 20 points Emily right there for some random. Has anyone here ever written a for loop? Has anyone ever here written a for loop? Nicole, 20 points for the hype. And also Ben and Brad and James being ready right here. Has anyone ever written a for loop? Corbin gets 20 points. Jacob, 20 points. Ryan, 20 points. Okay, so how important are those for loops? How important on a 1 to 10 scale is knowing how, Dennis right there, Dennis, yes. How important are for loops? Like of all the things I'm about to teach you in 11, they are the most important thing. Because imagine you have some code that you want to run 10,000 times. What you could do, we'll bring this in a small window now. So what you could do to run a code 10,000 times is you could take that line of code and maybe there's something to change like this right here. So this line of code right here has this and this changes. So this right here would change all the way like this, all the way down. It's not code. This line of code would go down and it's going to do it 1,000 times. So there's a super quick way to write this. And if you know the format of a for loop, you could do this. And this is why this assignment doesn't take too long if you know how to write everything. The best thing when you're writing a for loop, and you'll know this again when we get to 474 with the right functions. What do you think is the first thing I'm going to write when I write for loop? When I write a for loop, what's the first thing I'm going to write? This is a huge note you should take. Don't try to do more than this. Even I mean, I can do it if I want, but I don't. Write for. Pause. Don't. That's one pause. Don't write anything more. All I'm going to hit now is enter. Alex knows some stuff right there. Alex, 20 points. Great job. And everyone else, 20 points answering. Mary, you can get up to 80 points today. Big points today. Look at this. It filled in everything. Just so you can see it again. Watch. FOR. And then I hit enter. And it gives me this right here. Now, if you remember, we've got parentheses right here. This is because for loop is a what? For loop is a what for 20 points? First person right here who's got it. For loop is a what? Because it's got parentheses. For loop is the function. Austin, 20 points right there. Yep. Why are there 2 4s? I don't see the 2 4s. Which, clarify, Jonathan, I'll answer. And then right here, I'm throwing 100 points. We're breaking the rules for someone. You get over points. You get 100 total. What do these do? What do these squiggly brackets do. They're what brackets. So I call these brackets we put what inside of. Bing, Brennan, you're at 100. Nice job. And Austin right after. I'm putting you both at 100 right there. And Sylvia doing right there. And Dennis and Alex. Oh my gosh, what am I doing? So on the autocomplete. Oh, good question. Good question. 100 points right there. Let me see. Okay, that is that. I don't know what that does. I don't know what that does. It says it's a base function in R. It says these are basic control flow constructs of the R language. Function, I think it's still a for loop. Let me try. For I in 1 through 1000, and then we'll have to do that. We'll have to do our coding brackets by hand. And then we'll have to go here, and then we'll have to say print I. Yep. It looks like some people, well, thank you, Austin. Austin, you're at 100, if I didn't say that already. It looks like this is a snippet, and so I'm actually learning stuff here, because I just used the first one. I think a snippet, which if I'm guessing, this will be a snippet too. Yep. This is a snippet here, and this gives you this whole thing right here. So a snippet appears to be something they've pre-written out for you to make it easier. And then the while loop, the while right here is the while loop. So the snippet is like, hey, we've already done a little bit of work for you because you're going to probably write it this way. So you just click enter on a snippet and it fills in for you. Guess what else has a snippet? Fun. There's the snippet for fun, which is weird because function doesn't have it. I guess it does a partial match on that. I've learned about that lately. But this has a snippet and it gives you the snippet right there. So it does some of the work for you. So that's what is going on right there. Oh, and it does write function. Oh, huh. I mean, I guess there's things you just don't look at. I've written so many functions. You guys will probably see me doing it in class, and it already writes out fun function for you, but you write fun, and then it fills it out with everything you need. So you've got these snippets because it's much easier to write fun because F is for friends, who do stuff together. U is for ukulele, and it's for anywhere and anytime at all. You guys finished it off for me. You know what I'm talking about. So these snippets right here make life a lot easier. But guess what? There's only 3 things to learn for loops. There's only 3 things to learn. We have part A, part B, and part C. That's all you need to learn for a for loop. That's it. 3 things. What is this? What is this? What is this? Alex, 20 points right there. Thank you so much. I love it. I love it. So let's keep going here. Let's take a look. So we've got automation and simulation. Once again, this is the whole point of for loops, to make things faster, easier to do work. Just like it's, put it this way. I was working with Kenny, and he wanted to go to like tens of thousands of web pages and get information from them on baseball players. So he wanted to go to like tens of thousands because it's like, it was for like all the baseball players in a database going back to like 1950 or 1940. It was insane. It was just every baseball player that's existed. So how many pages does he have to write a code to scrape? How many pages does he have to write a code to scrape if he has 20,000 pages? So if he has 20,000 pages, how many pages does he have to write a code to scrape? This is the whole point of a for loop. How many pages? 20 points. Who knows how many pages out of the 20,000 pages does he have to write a code to scrape? Well, he'll scrape the 20,000, but he has to write a code that scrapes how many pages? Just one. Just one. 20 points, all those answers right there. Just one. Why would he just have to write a code that scrapes just one? Because this is a web page, so it probably has similar format, because they're not going to be like, okay, now we're going to totally change how the page works. Because I mean, I guess they could, and you might find that, like, maybe you'll find your code didn't work, it didn't scrape these players because they changed the format for certain years. You might find that, and then you have to write a different loop for those years. But let's just assume it's the same format for every player. With that said, if you scrape one player, and then you have your code do the same thing for the 20,000, do you see the loop? Like, you would do it for the first player, the second player, the third player, the fourth player, the fifth player, the sixth player, and you would keep doing it for the 20,000th player. So your code would be very small. You would just have a code that goes to the web page, downloads the table, and saves the table. And then you might append it onto your data set with something like would be row bind because you're binding new players. So you might just keep appending on your data set and growing a data set as you do this. As long as you know how to scrape one web page, you could download 20,000 web pages and append them all into a data set. Just think about the power of that, because I've heard stories from people. It was like a student told me his friend had a job working for the government, and they had him do some work, and he wrote some code that did it all for them, that basically did his job, and they were like not happy. They're like, wait, so now you don't have to do this anymore? And he's like, yeah, the automated code just does it every day. And they're like, well, that's what you're supposed to do. You're supposed to go there and do this and do this and do this. He's like, well, yeah, now it just does it and saves it to the server in the file you asked me to. It goes there every day. It gets the information, and then it uploads the file every day. It's just set on a server time. And they're like, wait, you can't do that though. And he's like, well, I'll just be sitting behind a computer doing it. So why not let the code do it? And so it's, from what I've heard, one of our big issues right now is that Silicon Valley is taking a lot of, they don't like efficiency. They're like, wait a minute, we don't need to have someone doing this every day, working hours just to do something that is so easy, or not easy, but like tasks that can be automated. And then we have the talk of automation in our society, which is pretty interesting. But from what I've heard, Silicon Valley, it used to be that people would go to the government who had the high level, the innovation, but now Silicon Valley is taking a lot of the high level innovation people, importing, high level scientists. And so Silicon Valley is are the individuals pushing forward, innovation. And it's kind of a bummer to me because, we need people pushing innovation everywhere. That's what we want you to do. We want you to come up with new ideas. We want you to be the one being like, I'm going to go beyond what we're currently doing. And a lot of places value that. Don't worry. Like, I've heard more stories of places being excited that people come up with new ideas than people being like scared and being like, don't do that. So conditional formatting. So all this good stuff right here. All the if thens. We'll talk about the if right here. Has anyone done an if statement in Excel? Ifs are pretty easy. Like, I think if you practice these things, you just have to see them a whole bunch. Ifs, let's talk about if for a moment. We'll go through this in the notes. But if you do like if 2 equals 2, then we'll go right here and we'll say Brian. I think that'll work. No, looked for object Brian. I want to go Brian. There we go. How about this? If 2 does not equal 2, it does nothing. Cost loved if statements. My brain's breaking. Let's go here. And let's do else. Darren, we'll be talking about what these codes do in a moment. But if you understand these structures and what's going on right here and what will be printed, you understand how these codes work. And probably the most important one is if. And let's go here to this one, if else, and do a test like survey 10 $. Let's go to GPA, and let's say greater than or equal to 2.5, higher than, and then lower than. These are people who had higher GPAs than me in high school, and these are people who had lower GPAs. I need to call up my high school. Maybe I wonder if they're open today. I'll be like, hi, I just want to get the transcripts for Brian Stevens. They're like, who is this? I'll be like, it's Brian Stevens. I just want to know exactly my high school GPA. But it wasn't that good. I got a lot more serious in college. But my parents always remind me as I teach that I wasn't the best student. I was not. I mean, in graduate school, I worked really hard, but definitely not in high school, which is all right. It's not the end of the world. Everything went on. You don't believe it? I promise you. Especially, I've got a report card. I don't know if you guys could see it. I still have it. Like, it's in one of my memory things. So 4.5. Oh, that's all. If you had 4.5, whoa. And like I always tell students, it's like treat every semester as every part in your life as a new adventure, and just keep working hard because there's always like opportunities. So, Don't worry. Hey, assignment 1 didn't go well. You got it. We got assignment 2. We're going to get assignment 2 great grade. We got till Sunday. Got so much time. So much room for activities till then. So let's do this right here. We've got the if then statements. No, you did. I had a 4.5. No, Jonathan, 20 points, Emily, 20 points. No. Our own user defined functions. We won't do this in this class, but user defined functions are so important. I love making my own functions. It's so helpful, just makes life easier because you can write your own function to do what you want. You'll see me do this randomly, but it's a huge help to write your own function because you can just have it do what you want. One of the easiest functions I write that you'll see me have people practice to do is just doing something like 2 plus or adding 2 numbers. So adding your own things together could be like A and B. What am I inserting into here? This is a review you should know. These are going to be the whats of my function that I create. The things right here are the different whats. I'll stay on them before changing topic. These are the different whats. They're inside of this part separate by, yep, Austin, 20 points, Austin, great job. Those are the different arguments. And then we go here. And then we go here. And guess what? If we go to add 2 things, I can go 5 and 4, and it adds them. I could go here and change the logic of this, and now it multiplies them. It's still called add 2 things, but now we just have multiplied. And just look at how this works. We've got right here, I'm defining the function with these arguments, and then it has these arguments right here, and it just inputs whatever I put for A right here, and it inputs for what I put for B right here, and that's how it works. You can even do things like put in defaults. Now, with these defaults in here, I actually don't have to run anything, and this function will produce 64 with nothing in it, because by default, A is equal to 8. You see even it shows me right there, and B is equal to 8 also. It does that by default now. I could change what B and A are, but it has defaults in there. But don't worry, this is not what we're doing right now, but it's a very, very important thing. Being able to write your own functions, get everything running. I saw a really cool video yesterday. I need to go back and watch it, but somebody was... they're a really good coder, and I was like, wow, they were using code to go to Spotify and go to YouTube, and if they liked a video on YouTube, then that video would be added to their Spotify playlist. So all they had to do was like a video on YouTube, and then that video would be added to their Spotify, and they did it with like Python code. Go look it up. She was such a great coder, and I was like, because I tried to find inspiring coding videos, and then I was like, oh man, this video is so good. She like totally, like she explained it really well, and like her logic was really great, and I was like, I need to write better coding videos. This is like, because I'm trying to come up with new video ideas, and I was like, this is such, because like, what better practical usage of coding than does anyone here have Spotify? Does anyone here watch YouTube? If you say you don't watch YouTube, I think you're a liar. Does anybody have Spotify? A really cool app that does stuff. Oh, really? IFFTTTT? Alex, send me more info on that. Apple Music. So think about this. If you're on YouTube and you just simply like a song, like the idea of, like, if you're on YouTube and all you have to do is like you're listening to something, you're like, oh, I like this. And then it would add to your Spotify playlist. That's awesome. Like, how much easier can it be? $5 a month? Yeah, maybe I should get Spotify. I don't know. Maybe I should. I've never had Spotify, but it seems like it's a good way to, I mean, just remember back in the day when you had to buy every song for $1, and now it's just like you can just have unlimited. That's awesome. See, my music tastes are so off the wall. I listen to a lot of K-pop. I think I've already told you guys that. So for like Brian, it's good. I like Black Bee and had Spotify since 2010. It's amazing. You could Napster, and was that? Yeah, there was like LimeWire and Napster and all those things. That's so, oh man, Brad, it goes back right there. I'm also like a big fan of like piano and stuff like that, like Ben Folds. Ben Folds, one of my favorites. So piano and stuff like that. That's piano's best. But either that or like eclectic music. Like, I don't know. Like, I like a lot of like global music. Like, I like hearing what the world's doing because, man, when you what's really, this is my last little side on this. Hey, good job, Emily. Um, like, uh, like K-pop has become very big across the world, but the U.S. we're like Blackpink is huge. I'm sure people here, someone knows of Blackpink in the chat, obviously, and but in the U.S. a lot of people don't, but they're huge, mega stars across the world, and they're breaking records like BTS, Blackpink are breaking records, and then you've just got a lot of other bands. So Dolph, I don't know what that is. If this then that. Oh, that is so cool, Alex. That is so cool. Yes, I will check that out. I'm surprised I don't. If this then that, it's literally like what we're doing in this class today. And you can see the importance of coding, that people are using these things. And it's literally the coding logic. Like, if this is true, then do this. Like, if this, then do that. So much to learn. We got this. Let's see right here. Who's good on this right here? Is anybody good? Alex, I'm putting you at 100, Alex, if I hadn't. Alex, I think I've already put you at 100. Alex, you're at 150. That's some practical usage right there. Alex, you're at 150. I like it. I broke the rules again. I'm always breaking the rules. So we have right here that we're saving into X an expression, just creating an object in the global environment. Is everyone good on this? Understand what's going on? We just save it into the global environment. Where will this go? I say this goes into the brain of R. So everything I've been saving right here, you see my X and my Y. These are all saved into the brain of R. So those are saved into the brain. Here we go, just some objects being saved. Left arrowing in, right arrowing in, equaling in. Like this is, who feels like this is a review? Who feels like today's been pretty easy so far? I know I've shown you some advanced things, but this is all we've had to do so far is we left arrow stuff in. We right arrow stuff in. We can equals it in. Now, I don't like the equals because I don't use it for that. But if you do, not the end of the world. See, look, today's a good day. Thank you, Emily. 20 points, Emily, right there. Emily, we're putting you at 100 if we haven't yet. So evaluate this right here. So here is something that maybe gave a lot of people trouble. Don't worry, I was correcting people's work. What you notice here, I'll go in this way right here, is that these E's are EXP. So when you write out something that is an expression like this, you have to change it from E to EXP. Now, E is also 2.7182818284594. You could write it out that way. Either which way is fine, but make sure you convert these things. I think a lot of people forget that we can't just put it in just like as an expression. We have to change it into logic R can use. So all that right there. Yeah, that'd be great. Let me add you right here, Jordan. Yeah, I'll have to look into that. I will have to look into that to do that. That'd be awesome, Jordan. That's a really good idea. Another example of saving. Cool. Ah, what happened? Go to next slide. There we go. Left arrow versus right arrow. It doesn't matter which you use, but it's like when this comes down to it, I usually left arrow everything in. Like my favorite way to save stuff is to say like X, left arrow into 2. Whoops. There are 12 warnings. I think I overwrote something. Okay. Don't know why it's getting mad at me today. But 2 is being saved into X. You could say 2 right arrow into, oh, not 2, X. And we have that right here. I'm just so used to putting the thing on the side I want to save into. But just imagine this flowing through. Just imagine this flowing through. That's why I don't like the equals. Equals is the same thing as a left arrow. And so this technically goes this way like this, but I don't like that it doesn't show the directionality of it. That's one of my problems with it. Other problem is that I use it for functions, like to say this is equal to this in a function. So make sure you understand that usually you kind of evaluate what's over here. Like the way I would read this is 4 plus 8 will be evaluated and then saved into X. So I guess that, makes sense. Like I should maybe try to read it to you guys that way, like 4 plus 8 equals 12. This will then be saved into X. So you can see that X, if we were to call it after this, would be 12. So X is not 4, and then we add 8 to it. It's that we evaluate this, and then we save it into X. Just understanding the syntax of how everything works. And great job on the points, everyone. Keep working on those points. We've got points everywhere. Remember, you can get these extra points by listening live. So listen live. Example of many operations. Do you guys feel like this is this too small? Like I'm looking at it and I'm like, I don't know if you guys can read that really well. That seems a little bit small to me. Let me look. I'll see what you guys say here in a moment. I want you guys. It is pretty small. See, this is fine right here. I wonder if it is small. Yeah. It is small but visible. It's pretty hard to read at times. Let me see. We'll keep going on. That's why I do a lot of examples, because I make sure on this right here that this is really big for you to see. So I think it's just because we have so much on the screen that the coding font is a lot smaller. There's plenty of space. Yeah, we know we might need to expand. You see, if I expand it, see here, watch this. See, I don't think that looks any better. It's still hard to see right here, right? What I can do though, and this is what I'll try to do. Go back. When I'm talking about this code in here, I'll try to zoom in on it. Please tell me to zoom if you want me to zoom in. But when I'm talking about code like this, I can zoom in on it. That way we could talk about these expressions. But there's so much going on here. It's just showing tons of different expressions that we can do. But please feel free in the chat to ask me to zoom in at times if you like can't read it when it's like small like that. But I will also, when I do code, try to do it over here so we can see it. Yeah, it's just slides and it's like on a smaller screen, and this is still pretty maxed out. Like this is still pretty large, like almost taking up as much as we can take up space-wise. See what I can do. I'll set this up for tomorrow. I can make a super zoom, which I'll try to set it up for tomorrow. Let's do it. I'm just not going to set it up right now because I don't want to spend yeah, we got it. We'll do it. All right, so let's go right here. Just conventions, notes about saving, uppercase for data frames, lowercase for vectors inside of them. So recursive assignment, everything going on right here. We're going to get to some new stuff. Vector assignment, we've talked about this. Factors are categorical variables. Factors levels are just the levels. If there's a Brian, there's in the call 20 points right there. I like that. Adding a new level to a factor, reviewing. These are all review right here. I'm just going to go through this because that is all review. Here we go. We've reviewed. We've talked about things we know. Now it's time for something we don't know. And so we should get through this by Friday, and we will probably do a little bit more new material tomorrow. But let's learn about for loops. We're only going to learn about for loops in this class, not while loops. While loops are great, but you're only responsible for for loops. So here we go. Big new material. So when it comes to a for loop, the goal of a for loop is to write a skeleton. This is a key word. The skeleton was what I told you a long time ago, and it's going to be the code that repeats. So is the skeleton A, B, or C? The skeleton will be the code that repeats. So the skeleton will be the code. Where's the code that where would the code that repeats be inside of this? Where would the code that repeats be? It is C. Great job right there. Casey and everyone else, 20 points right here. That's the skeleton. And think, since it's the code that repeats, it's going to be right inside of here, because this is where the code is at. Remember how we said this is a code bracket right here, that we run code inside of this? If you can't tell, it's like a squiggly bracket. Just so you can see, I'm going to write it really big right here. We're going to open up a new document. We're just going to write this. It looks like not with that. It looks like this right here. These are coding brackets. So that's what that looks like if we were to zoom in on it. It's a coding bracket. And so we have that right there. That's a code bracket. And so now we have the skeleton. And what we do is we want this code to repeat a certain number of times, but we want this code to change something. We want every time the code runs, this is like the theory of a for loop, is we run a code repeatedly, and every time the code runs, we change something in the code just a little bit. So we're able to manipulate code as it runs repeatedly. So what would be, for Kenny, what would be the thing that would change every time he runs his code for baseball players? So who here can figure out? 100 points, first person. You get up to 100 points. You get your 100 point super max of the day. What would change for Kenny? I'll take name right there, Brad right there, the name of the baseball player. Yep. And the way it worked for him, name of baseball player is pretty much what it's doing, but you'd have to, if you had a list of all the names of baseball players, you could do that. And identifier, I like that even better, Brad, because maybe each player has an ID on the site, and they would probably label all the players like 1 through 20,000. And there was actually a URL, and he just looped through all the URLs because the URL had the ID of the player, and he would just loop through it. And that's pretty much because the unique ID, yep, it's an identifier. So it's back to 201 again. We're talking about identifiers, and he just loops through and changes the identifier, and then it goes and grabs this baseball player, then this baseball player, then this baseball player, then this baseball player. That's how it works. It's what it does. So running a for loop is a time saver. That's why we do it. So you can do things without a loop. Like could you imagine Kenny saying to me, Brian, I don't need a for loop. I'm going to get the data on all these 20,000 baseball players by going to each website and then recording it. Like I'm going to type each number into an Excel spreadsheet. Then I'm going to go to the next website. I'm going to type each number into the Excel spreadsheet. They're trying to make the tapping noises. I'm going to go to another website, type each number into the Excel spreadsheet. Could you imagine that? It can take a while to write a for loop. Like a good for loop can take a little bit of time, but once he's written it, he's got it. So it would be insane to, if you have coding knowledge, it would be crazy to go to sites individually and be like, I'm going to go to this site and write down the data. Now, if you only have to go to like 2 sites, you'd be like, okay, I've just got to go to 2 sites and record stuff. Okay. I mean, even if you know coding, you're like, okay, I just got to go to 2 sites. But that's what we do is we write code to make things faster and easier. And you could just do it by hand, but way easier, way easier. So this is the big thing. If there's a task that needs to be repeated, then we use for loops. And here's where we're going to see the control structure, how we make the for loop do its repeated motion. And so here we go right here. I'm going to copy this code in. And you know what? I'm not going to go to the next page. Let's see if we can figure out how to turn this into a for loop. You ready? I'm going to teach you how to write a for loop. And if you're watching this, you can start doing the assignment. So take a look at the assignment after this. We have X is being saved into 3. Let me tell you how to identify a skeleton. A skeleton is a code that repeats. Line what through what is the skeleton here. Line what through what is a skeleton. Line what through what is a skeleton. It's code that repeats. Not literally repeats, but where it's basically the same thing. Line what through what is a skeleton. If you follow this and understand this 44 through 49, yep, these right here will turn into our skeleton because this code is just repeating. Great job, 20 points. Keep it up. If you're seeing this, you're getting it. We're going to copy one of these and we're going to go here. Where does the skeleton go? Where does the skeleton go? Right here. Skeleton goes inside the for loop. So we have our skeleton inside of there. It's like our inside. But this is not ready to go yet because now we just have to learn about these 2 things right here. So let's talk about what a variable is. A variable is just a placeholder for what we want to change. Take that note down. I want to see it for 20 points in the chat. The variable is the placeholder for what we want to change. The variable is the placeholder for what we want to change. Go random. The variable is the placeholder for what we want. Yep. So it's just going to be a placeholder for what we want to change. Yes. Crack me out there. Oh, man. So what I'm going to do right here is I'm going to put in I. Does everyone see that? I've just put in I. And I'll tell you why I'm using I. I could use Brian. That's fine. Wherever Brian is in this code, it will change Brian. So if I put Brian anywhere here, it'll change that to it'll change Brian every time the code runs. So C can be any line in this. So the skeleton can be one line, but everything inside of here, like let's say there was multiple things, everything inside of here. So this would all be the skeleton. Great question there, Jonathan. Everything inside from here to here is the skeleton. So this is where the skeleton begins and this is where it ends. And so you can have a larger skeleton. So it's just, it's anatomy. So the skeleton is everything inside of there. And so now we're just going to call this placeholder right here I. I'm using it because it's positions. That's why I chose I. You can choose anything you want, though. It's just a name for what we want to change. And then I want us to think. The vector, and write this down, this is key, are the elements that I will change through, or are the elements the variable will change through. It's I right now. The vector are the elements the variable will change through. The vector are the elements the variable will change through. So write down 20 points. The vector is the elements the variable will change through. I don't know grammar. So vector are the elements the variable will change through. Exactly. And these are notes you should have. These are like, be writing these down. So when you choose your vector, you have to say, I'm going to go through these numbers every time the code runs. Like you're going to start with the first, then you're going to go to the second number, or what it can be a number, or it can be different things. That's why I said elements. It can be like names. Like imagine I did this. Let's go here to family. And I go here to Darren, Brian, everyone knows my family's names now, and Emily. And then I go here to 4, and I go names in family, and I go right here and I say print names, and we run it. There it goes. There's a for loop. So this right here being family, the first element of family is Darren, then Brian, then Emily. So the first time the for loop runs, it goes here and it puts names and changes that into Darren, and then it prints Darren. Then it goes and puts names into Brian into names and prints Brian. Then it goes and puts Emily into names and prints Emily. So seeing this right here, this very, very quick for loop, which doesn't really do much of anything for us. So we want to now think about what we want to do here. Actually, Brennan, great question. Global environment has Emily saved into it. Because remember how I said when this for loop runs, it saves, if we could see it in slow-mo, we'd see Darren saved into names, then Brian saved into names, and then Emily saved into names. And that's why at the very end of the for loop, Emily is saved into names. Brennan, 150 points. Amazing question to ask, because that's what it's doing. Every time the for loop runs, it saves Darren into names, runs the skeleton. Saves Brian into names, runs the skeleton. Saves Emily into names, runs the skeletons. So what's in names at the very end of this? Emily. That's a really good question I could put on the test. I could say, what is the value of names in the global environment after the for loop runs? And then it would be whatever the last thing was that it ran on. So, you could put in here, we could test this out by going right here and just going to Tolliver. And then, graphics error. Don't worry about that. And then we run this right here. You can see the final thing in there is Tolliver. And if you were to put another Brian here or something, sure, Brian with an O. And then you see now Brian with an O is in there, B-R-I-O-N. That's the oddest spelling of Brian I've seen. Still fine, but oddest spelling I've seen. So you can see what's happening right there, that the code when it runs is actually changing what is in names. So in our example right here, what do we want to change? What do we want to change? Look at this right here. Tell me one of the values that will change in this code. One of the values that will change in this code. Like look at line 44 and tell me one of the things that will change when this code goes to line 45. What will change in our code? Any ideas what will change? From 44 to 45, what changes? From 45 to 46? Kind of. Well, so you are right. X will change. We're overriding X. But do you see anything like, kind of? Give me a number that changes. Like on line 44, there's numbers. And what of those numbers is then changing on line? You're right, Henry. The position of X, you got it. That's a very good answer. I like that a lot. And 20 points, all those answers. Thank you so much. it's the position of x. So watch this. What if I call this, let's call this I right here. So when I run this for loop, if this is I, do you see how this is I now? Then what is this the first time it runs? What should 2 become if this is I? Then what should 2 be mathematically? If 1 is I, then what should 2 be mathematically? You got it. There we go. Does that make sense? Because if I is 1. Now, wait a minute. The first time the for loop runs, I will be 1. Does everyone understand the first time the for loop runs, we want I to be 1? So wait. I should be 1 and go through what? The for loop should use I as 1 and then run repeatedly through what? It should go from 1 to what? The for loop should go from 1 to what? Who knows? You got it, Ryan. Amazing job. We just ran our for loop. We just did it. We can confirm this. We'll put X right here. And we'll put this right here. So we'll restart the code. So let's run this. And then there's that. So take a look at that right there. Let's run this. And there it is. Same code. But here's what's awesome about a for loop. You ready? Imagine if we wanted to do this 100 times. No, I don't want it to say that. If we wanted to do this 100 times, I guess this would be 101, and then this would be 100. Could you imagine writing this all out, making a vector here like this? Why not just do this? There you go. You want to do it 1,000 times? 1,000 times. There you go. 1,000 times. We just ran that code 1,000 times. Done. Just like that. All I had to change was how many times the code ran. And now, you know, you can just go up here and you could kind of show what it does to people because the code is going to do this 1,000 times. So the code here is now doing it. How does it know what I is? Because remember, this right here, and we could call this like change this. So wherever change this is at, which is just the vector, excuse me, the variable, excuse me. The variable is what it'll change. Does that make, this is what is going to be changed. So every time this runs, it changes whatever this is right here. Like this right here is this what will change. And it changes the first time, change this becomes what? The first time it runs, change this becomes. And the second time it runs, change this becomes. How does it know to increase from 1 to 2 to 3? Because of this right here. Because these are the numbers. And here I'll show you a different one. Watch this. 4. Let's go number. And let's go concatenate 4, 7, 2, 3, 5. Okay. So now let's go here to random. And let's go number plus 2. At the end of this right here, and I think we actually need to declare this. Let's see if it does it. Is it going to say it can't find random? No, it did it. Here's a big question worth 200 points for today. I'll put you at 200. What is the value of random in the global environment right now? What is the value of random in the global environment right now? Who knows the value of random in the global environment right now? You could get the right answer, but be wrong. Austin, 200 points you're at today. Amazing. Yep. And so the value of random in the global environment is 7. Yep. Wow, man. 100 points everyone answering. Like, if you understood that, you're getting it to a certain degree, I think. The first time it runs, here's what I could do, is I could go in here. This would be, let me do this. Random, if you were to run this, it would have an issue maybe. Random blank vector. This is how you create something blank. So this code right here, don't worry, it didn't have a problem. This code right here creates a blank random in the global environment, just creates an empty vector of random. And now I'm going to go here and I'm going to store into position I, and I'm going to go here. I'm going to go to I is equal to 1, and then I'm going to go here and go to I is equal to I plus 1. And now we can see random is a vector of that. So the first time this ran, the first time this code ran, what did number become? The first time this code runs, number becomes what? The first time it runs, number has changed into what? Number changes into, what does number become? Number is, first time the code runs, number is 4. Yeah, there you go. No, perfect. You were solving it. And then you see I is currently 1. And then it'll go here and it'll add 1 to I. Does that make sense? It'll overwrite I with I plus 1, so I will become 2. The second time the code runs, we put in 7, and this is where the 9 is coming from, and I is currently 2. Now I will be 2 plus 1, which is 3. So we're changing what I is also inside of here. And now this becomes 2, and I is currently 3. So if you look down here, it's saved 2 plus 2 into position 4. And then we'll go here, and I will become 4. So now the next time we run, we put in 3. And then this is position 4. So that's what's saved right there. And then the last time it runs, I becomes 5. And then this is saved into position 5. Is this making a little bit more sense as you see how the code is done right here and just realizing it's just looping through and going through all the elements of the vector? That's why this one up here started with 1. You don't have to start with 1, though. You don't have to start with 1. This loop right here starts with what? Yeah, it's kind of like that. It is. Brendan, 20 points right there. Excellent work. This loop right here starts with its first element being what? What is the first element of this loop? What's the integer at the end of the equation? Oh, you could use a sequence. You could change this right here. This is a problem that you could go 1 through 1000 by 2. So you could put a sequence, and then it'll change this right here every time. So you could change the way it increases every time with a sequence. So whatever is here is what it'll go through. Like this is the part B is the what will change every time. Like the first time this runs, it'll be 1. The second time it runs, it'll be 3. The third time it runs, it'll be 5. So it just goes through these elements right here. Does that make sense, Henry? That it just goes through the elements in the sequence. And our sequence right here goes 1, 2, 3, 4, 5, 6, 7, 8, 9 because it's just the that sequence. This sequence right here has a totally different order. So you could manually type into this something like 1, 3, 5, 7, 9, but it's easier to do a sequence from 1 to 9 going by 2. Those are about the same length of writing out code. And then we want to put this back here, just in case people want to write, oh, that has to be I. And so now, this sequence right here, the first time it runs, it puts Darren in. Do you see how family is a vector of just names in my family, except for Brian? And we have Darren, print Darren, Brian, print Brian, Emily, print Emily, Brian, print Brian. So this right here is just going to be different names being printed, and every time it runs, it changes it just a little bit. I'll show you one example, much like your assignment. Maybe it'll be, I'm kind of even doing it now. I'm trying to remember, I wonder if I can remember the assignment, off the top of my head right now. Watch this. Let's go here to data EX2 tips. So I'm going to basically do an assignment question for you right now. So don't worry if you're paying attention, if you've been following along, I'm about to do one of your assignment questions, very similar if I'm remembering off the top of my head the homework. So here's what we want to do, is we want to go and we want to look at the tips people get during the days of the week. So let's go here to the EX2 tips data frame, and let's look at the tips people get right here, the tip percentage right here. Here's their tip percentages. And then what we want to do is we want to figure out their mean tip. How will I find out mean tip? Just tell, what do I do? What function? There's silence. I'm scared. 20 point. You got it, Brad, right there. Mean. Boom. But here's the thing. I want to do it for a day of the week. So if I want to do it for the day of the week, I need to make a what now? If I want to do this for the day of the week, I need to make a what to do it for a day of the week. And actually, there's quite a lot of ways to do it. Sorry, something was in my hair. If we want to do it for a day of the week, I have to make a what? If we want to do it for a day of the week, we have to do it for a what? Got it, subset. Nice job, Alex, right there. We'll go to subset, and now we're going to subset ex2 tips, and then we go here. I'm now writing a condition, and I want to do, is it day of the week? I'm going to go down here so I can see. I'm going to find the column name down here. It is weekday equal, is that weekday, yes, no? I think that might be weekday, yes, no. Day or night, weekday, is it? Let me look at what weekday is. ex2 tips, $ weekday. Oh, good. No, it is what I thought it was. So now we're going to go here. We're going to pick something like Friday. And this should be only Fridays. So let's call this sub. And now we've made a subset. We can confirm that this is just Friday by going to weekday. And oh. My brain is not on. There we go. Two issues. That's what happens when we don't think. Don't worry. Switching between functions and logicals, sometimes you make a mistake. And then always look at what you create. But does my subset only have Friday in it? Do you notice how my subset only has Friday? So guess what now? Now, we just want to go here. Instead of taking the mean for our full data set, we want the mean for Friday. Did everyone see this? What has Brian just written? You get 200 points. I've just written most of my what for my for loop. 200 points. We're going crazy with the points today. It's only one person who gets this, though. I've written most of my what. Because here's a hint. Yep. Who was first here? Brad right there. Brad. Nice job, Brad. You got it, Brad. Brad, 200 points. This is my skeleton. 20 points everyone else. Probably getting that max 60. And some people got some crazy extra credit today. Great job. So what we notice right here is we're going to go to our for loop. And when we do our for loop right here, we want to save our output from this. So we're going to go here to daily tips. So let's go here to daily tips. And if you're going to store into something, this is a huge note that you should take. We often create it outside the for loop. Please take that note down. That if you're going to store into something in the for loop, you should create it outside the for loop. So my end goal of this for loop right here will be to store into daily tips. I'll put it here for the moment. And I want to store into position Friday. I'm going to store into position Friday, which I can do. Position Friday right here will have stored into it this value. Does this make sense right here that when I do this, I will store into position Friday because it's a named vector. I'm calling the name, if you remember how we can do a named vector, Friday is position 1. I could go here and call Saturday, and now Saturday has been stored as position 2. Now I did put Friday's value into it, but I just wanted to do it quickly there. But it's not too hard to store Saturday in here. Look at this. I can do the full for loop right here. Now Thursday's over here, or Sunday. Don't like that. It's got that space. I swear that didn't happen before. There's that. Now we go here. And no space. And last but not least, and guess what? We just ran our for loop manually. I just did the for loop by changing it. So I've now done a for loop. If everyone saw as I changed the values. But let's think about this. We have right here the code and what was Brian changing. What is this for 200 points? This right here is the what. This is what was changing. This is what was changing. Who knows? 200 points first person. This is what is changing. Variable right there. That is the variable. Yep. That is what we'll have to put in. Nice job right there. It was James was first. Nice job, James. Excellent. 200 points there, James. So you see I put this all inside the for loop. And let's just go here and call this day. Do you see how I changed it? Because this is what I was changing every time I was writing the code. So every time I wrote the code, I changed this to this right here. Does that make sense that this was what was changing? This is telling it what to change. You can, if I gave you over, then you have to listen. You have to be like, Brian's breaking the rules for me. So it was 80, but remember, you only get to break the rules if Brian's like, I'm breaking the rules and you get 200. It's sorry if it's a little bit confusing, but so I think Jonathan, you released at 100. Sorry. Some of those, like, got to pay attention carefully because even Brian doesn't know the rules. So the vector, this is where people get confused on this one. On the vector for this one can be written so easily. Now, what we could do is we could do it the hard way. We could go here and go to the levels and copy paste these and go here and type these in like this. Now, this is not so hard, but, you know, it's more work than I like. So does everyone see what I'm doing right here? I'm putting in these right here because the first time this code runs, you know what you could do? You could then make it so it goes in order by changing this. It's not so bad right here now that I look at it, but you could put them in the order you want. Does this make sense? Because watch this. Now, there you go. And all you have to run is this code right here. Done. But how about this? Does anyone know a code I could run to see all the levels of day of the week in this variable? I'm basically saying it because all we want to do is go through the levels of day of the week. So if we go to levels and go to EX2, day of the week, weekday right there. Look at that. And let's just go here and put this right here. Because what is this? It's this. Jonathan, nice job right there. It is this right here. Does that make sense that this code right here is a vector? And so now we can run this. But we're going to see something that maybe makes us mad. We're going to be like, no, Friday is now at the start. But watch this. Why not put Thursday at the start with the following? Run position 4, position 1, position 2, position 3. Up, we have an error. Because of levels. What happened? Oh, haha. I did a 4-dimensional object. This one's making code too quick. There we go. And now we've done it. So this is where we want you to be at with this assignment. What you've just seen right here, and don't worry, we're not ending yet, but what you've just seen right here is where we want you to be at the end of this assignment. You might be thinking, whoa, no way. But I want you to look at the steps. Please write this down. Put it in the chat for 20 points. I know I've offered a lot of those today. But what is the first thing Brian wrote when he wrote his for loop? The first thing Brian wrote when he wrote his for loop was he wrote his what? Brian wrote his what? What did Brian write? I'm giving a hint right here. I wrote 4. I'll take that. I wrote 4, and then I wrote my what. You're seeing it right there. You're seeing it. I wrote the skeleton. I wrote my skeleton first. I wrote the code I wanted to repeat, and then I made sure it worked. Because then all I had to do was take and change this. The whole point of my for loop. So remember what we talked about with Kenny? When he wants to scrape web pages, he scrapes one web page. He just makes sure his code works on one web page, and then it should work on all the web pages. So all he does is gets a code to scrape one web page, and then he runs his code over repeated web pages. So that's the goal right there. Get it to work one time, and then you can just repeat it multiple times. So once I knew that my code worked, this code inside of here is the exact same code that's inside of this for loop. This whole code right here is the skeleton, and then the skeleton just changes what day is. Day will first be the 4th element of this vector, then it'll be the first, and I did this to reorder it. So if you're saying, wait, Brian, why did you do this right here, this whole concatenate thing? Well, without this, the order for this has Friday first. So I said, nope, I want Thursday, which is element 4, to be the first thing we run in this right here. So does it make sense that Thursday was the 4th thing we ran? So, it's the 4th element, but it was the first thing we ran. And then it went Friday, Saturday, Sunday. And that's where you see Friday, Saturday, Sunday. So I was able to easily reorder this right here by calling the positions and running it in that order. So if you notice, everything you're seeing here builds. And these things we're doing right here are some of the most important and powerful things we can do in coding. So this could be a weekly report you get every week. So very, 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 very good stuff right here. Let's take a look a little bit more. Lots of examples in the slides, but that's got a big thing for for loops. There's the for loop we wrote out, so you can see it. Here we go with what the skeleton is. I'll zoom in a little bit here. But inside of the skeleton, you have your for loop. Here's the looping variable. This is what will change every time the code runs. These are the values it'll go through. And then we have the skeleton, which can be a lot longer. So the skeleton can be many, 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 many lines of code, as you just saw with mine right here. The skeleton is very important, knowing exactly what is going on right here. Can I zoom out? There we go. So what happens in the for loop? We just loop, and every time the for loop runs, it changes what the looping variable is. So, I could say, like, what is the thing that we will change every time the for loop runs? And what we will change is the looping variable. The skeleton stays the same. It's just the variable inside of it, right here, day changes. Like this is the skeleton. The skeleton now has the placeholder of day. Does that make sense that the skeleton never changes? Every time this for loop runs, it runs this code right here. The for loop is always running this code, but the first time it runs, day becomes the fourth element of this, which is Thursday. Then the second time it runs, it becomes the first element, which was Friday. So every time the code runs, it changes what day is. Very, very, very important right there. All this right here just explains everything we've been talking about. And let's look at one more example to end class. And that'll do it for for loops for today. For loop right here. It's too simple of a one. Let's look at a fun for loop example. I think, do we have the sailor? Oh, no, that's a while loop. It's so fun, though. So let's see right here. Weighted grades. Pretty good example right here. And I think we have this, do we? We have, it makes a matrix, so we're good. So right here, if you notice, I can do this across all my students right here, write a for loop so that I can compute grades. We'll drop this into R right here. And let's hop to the main screen. Let's do it. Let's do something. Oop, we got just enough time for one more for loop. Let's take a look right here. We've got here that we're setting the screens, we're setting the seed. Now this code right here, don't leave yet. Remember, we got a little bit more time. What does set seed do? I put this on the midterm sometimes and no one gets it. Not no one, but what does set seed do? Has anyone ever played Minecraft? Do you want to join my Minecraft server? We actually do have a Minecraft server. I need to join it. Has anyone ever played Minecraft? If I tell you go to Minecraft seed, yes, you know what I'm talking about right there. If you go to a Minecraft seed, like if you and I go to the same Minecraft seed, what will happen? If we go to the, yes, Alex, perfect answer. Yep, because if we go to the same seed, we get the same world. So if you go to this seed right here, you'll get the same randomness, which we have had weird issues with this because of versions of R. But if you run this, the grades will be the exact same. Look at this right here. It's 0.927. And then look right here, we'll run it again. We'll look at grades, and it's 0.927. Because set seeds, you're the best. I got to show you guys my Minecraft world. I think it's still on my Xbox. And now we're getting weighted grades. And now we're going through here. And every time the code runs, it's going to go through each student, because each student's going to be like a row. And it's going to go from 1 through the length of weighted grades. It's going to go through all 10 students. And it's going to compute this right here, this score for them. And it's going to store this into WGI, or WG, position I. And so you see we run this, and now we can look at WG, and we got their weighted grades. Done. Code works. And it's pretty much just like an Excel spreadsheet right here. Like we're just going through. We could even append this if we turn the matrix into a, so we could go here, and let's try it. Oof, we got to do this. So we got to go to column bind. I think this should work. I wonder if you can, we might need to turn, let's do a few codes inside here. Column bind, data.frame, matrix, comma, WG. It says, I didn't close the matrix function. I didn't like. That's close. Can we turn the data frame matrix into a data frame? Not like that? No, it doesn't like that. Can we column bind the matrix? And these would be column binding, right? There we go. Oh, it's got question marks though. That's not good. The matrix. Oh, it doesn't. Wait a minute. What is the matrix object? Oh, wait. Oh my gosh. My brain did not work. And then we could go here to names. And these are just random grades. 1, 2, 3, 4, 5, and that's WG. So let's go to names of DF. And this will be it. We'll finish off with this example. There's 5 grades. We'll go to this. We'll go here to G1, G2, G3, G4, G Fuel, G5. No G Fuel yet. And then weighted grade. And then we go here to DF and we take, oh my gosh. Oh my gosh, what am I doing? Names of DF. What did I do? Oh, I don't know what I'm doing. But that's still variable. Names of data frame. It's not a data frame. And now, there we go. So that did it. We've got it renamed. We're good to go. And that's just a little bit at the end. So thank you guys very much. Sorry I went 1 minute over here. I just wanted to finish that off and kind of rename it and use some functions we've seen before. So if this is making sense to you right here, like how I column binded these together right here, and then I turned it into a data frame, I stored it into this DF object, I overwrote the names of DF. Who feels like this at least makes really good sense? Like you understand what this code is doing right here. And if you're wondering, I could just say, this is object X right here. Who here feels like this is making decent sense? And that turns X into a data frame. Like my code there makes decent sense. Like I put things together by the columns, turned it into a data frame, renamed the column names of a data frame, and then I printed the data frame to the screen. And that's what we get. We'll see. Good class today, everybody. Awesome work. Somewhat makes sense. Good. No, don't worry. It's like just practice. Feel good? Awesome. Yep, just practice, practice, practice. Excellent work. Yay. Well, I'm going to take a real quick break right here. I will be back. GG's. Good game. I'm about to go practice for it. Yep. And we should be getting data camp soon. Like, I don't know why they take, like, they used to get back to me in like 2 or 3 days, but we should be getting, here's the F that I was talking about, still doing office hours at, yep. Still doing office hours, swing by office hours. We can work on the assignment, jump on in, do the work, say, hey, let's do some work at 11:15. You guys got it. I will be back. Brian will return soon here. I will see everybody very, very shortly. See you soon, or hang around for 474 if you want. Bye. Bye. Bye.
Conversations has a somewhat looser feel to it.
Yeah, it's got an almost improvisational tone.
Hey, what's up, everybody? It's a happy Thursday morning. We got some Mega Man music in the background. Let's time it here so we could have some music and get hyped for the day. Said, how is everyone doing? We're doing great, it looks like. Good to see everyone here. Nitin and Andrew and Madeline and Sarah. And who else is here? We got Jonathan and Jinning. Good to see you here. Good morning. Good morning. I went and checked emails between classes. Good to see you, Anisha. Vedrana, good to see you. Everyone here. Everybody here. Carly. We need to make Carly a mod right here. Let's do it. I think we got this. Good morning, Jordan and Peyton. I love all the positivity. I love people saying hey to each other, just saying hey, good morning, everybody. Like, I'm gonna tag the most recent people in the chat right here. And there we go. Let's just tag some people right here. We're tagging so many people. Oh my gosh, I gotta make sure. There we go. I can't type. Looking down. Good morning. Yes. Good morning, everybody. Good morning. It is. See, you know what's nice? I love all my classes, but we start at 9:45, which is not a bad time to wake up. I'm not saying sleep till 9:45, but 8 a.m. Well, you know what's gonna be interesting when I'm in Texas. I'll be getting up at like 6:30 maybe, or like 6:10. No, wait a minute. I think I teach at 8, which will be 7 a.m. there, which means I need to get up at 6:10. You can adjust. You can just go to bed earlier. That's what people tell me. Just go to bed at a more regular time, and then you'll be fine. But 6 a.m. Man, it's like what we try to do, especially when I was in college, or like you try to get those like 10 a.m. classes or 11 a.m. classes, none of those 8 a.m. classes. But you guys know we got our 9:45 class. We're good. So let's do this. Are we ready? Now, we just had grades came in. There was a few people who got hit with excessive output. If you are ever worried about excessive output, please email me. So here's your biggest tip. If you are worried about excessive output, please just send me your file to look over. So if you got hit with it, if you got grade points off for excessive output, just be like, hey, Brian, I just want you to give this a look, see if it has excessive output. I'll give a look at it. I can't grade the whole thing, obviously, but I can look at it and be like, oh, you're good. Don't worry about it. And then if the grader takes off points, just tell me, because I want to make sure everything's in line. But the biggest thing is look over how you were graded. And if you see any issues, please tell me. Graders are not perfect. And what happens is I'm not perfect. And then I tell the grader to do things and they're not perfect. And so then you're getting a double impact of, I don't know. So things are, don't worry. All I'm trying to point out is sometimes things are graded too harshly. Sometimes you get a easier grading thing. But please look at your grade and see if you agree with how it was graded. If you don't agree, take screenshots of what you don't agree with, and then just send it to me and say, hey, Brian, I think a lot of points were taken off here. Can you explain why? And there's been many times I've given points back. Many times I've given points back. So then you're always free to ask. And I think I'll be posting the key later. Did I post the key for you guys yet? I think I posted your guys' key. No, I think I have your guys' key auto unlock. So I'll have to make sure the key is posted. So the key should be posted so you can double check stuff. And if you see any issues, if you see anything that's weird, tell me right away. Please tell me. And we will have our next assignment due tomorrow night. Wow. But who's been working on the assignment due tomorrow night, and what do you think of it? I think we ended. Let me go back. I need to go back in the notes. Who's been working on the assignment due tomorrow night, and what do you think about it? Who's been working on the assignment due tomorrow night, and what do you think about it? Anybody worked on it at all? Some people have already turned it in. So great job there. So kind of tough questions, though, and we'll be doing office hours today. So definitely. Was it due today? Why is my brain not working? It is due today. Let's think. It says it's due tonight. I think we could put it. We'll have it due tomorrow. How's that sound? Let's put it due tomorrow. I'm making executive decisions here. The assignment will now be due tomorrow. How's that sound? I'm always open to your guys' suggestions. So we roll by suggestions here. So, yep. So you're hearing it now. You're hearing it in class. This is where we talk about stuff. I just want you guys to know well, no, you just got to talk to me about these things. When, like, please, whatever you do, don't do this. I mean, you can write any review of me you want, but I've seen in reviews like didn't, like the class was too hard, blah, 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 blah. We're a team here. We are a team that works together. And once again, Dennis made the Discord. I know 320's been using it a lot. They've been doing the voice chat. Let me see. I should hop over to 320 voice chat. I should see if they're on the Discord. Like, are they in the Discord right now doing work? Let's find out. I'm totally hopping into the Discord. Let me hop in here. Where's the Discord? Up. Nope. Oh, wait. There's one person in the voice chat. Has anyone here used the Discord yet? And what do you think about it? Because there's voice channels on the Discord where you can talk to each other and like maybe help explain things, which I'm really hoping like next semester, especially when we have even more students, that the Discord is. What do you guys think of the Discord? Anyone using it? And if you haven't, maybe give it a shot. Maybe go on there. Maybe schedule times with people to say, hey, 5 p.m. tonight, we're going to do it. It's easier than discussion on Canvas. Yeah. So Alex, yeah, check it out and we can help explain how to use Discord. It's basically like a chat room type thing. And of course, all the rules of, being a UT student applies. Make sure you're just treating each other with respect and help each other out. And so Hannah, I guess maybe you haven't used it either. Dennis, thank you, Dennis. Dennis, you're being awesome. Dennis, do you want to drop your email in the chat? If you want, it's your call. It's really useful. Discord's a really great kind of organization app. And then I want to grow what we have. You can even set up bots and stuff. Like I use it for Pokemon Go, and you could, like maybe we could set up Dennis, I don't want to give you more work. I'll try to figure these things out because I was thinking a bot where people could like schedule study sessions. Like you could put in, and then it would make a list, and you could see what study sessions are scheduled and who's going to attend them. So you could put in a bot feature, a command that like will sign you up for a study session. So you could run an argument that's like, I can't remember how to run arguments, but it would be like, study sessions, and you could do like study, and then it's not ran like this. I can't remember how to do the things in Discord anymore. And then it would show you, like, it would report back, like, there are 2 study sessions, or like open study sessions are, I would say like open study sessions are, and then it would report, and then you'd say sign up. So you'd do like sign up. Is it exclamation? I haven't done these things in a while. And you'd put in here like sign up 2 p.m. and then it would put right there. That will put a message in Discord every time you upload a YouTube video after the class is over. Oh, cool. Oh, wait, you do? Dennis, you are the man. The bot. Whoa, I got to upload an. Dennis, you really are very good at this. Thank you, Dennis. I need to talk to you about this more. Dennis, do you have experience with like Adobe Photoshop and stuff like that? Because, I am looking for a student worker, and you're really, we're trying to do the new online stuff, and you got a lot of expertise in this stuff, and having you as a student worker might be really awesome because then you'd make a little money on the side. But you've been doing all this for free, and I really appreciate it. I need to talk to you about this stuff. So, and you've been doing all this for free, and we really appreciate it. So, if you want to drop your email in the chat, Dennis, just throw your email in the chat, and as long as you're okay with people emailing you, or if you prefer they talk to you via Discord, or but just thank you for helping people out and helping us build more community here, where we can work together on stuff. And email me if you want. I'll try to put together more stuff on how to do it. Thank you so much. Yeah, you're awesome, Dennis. I really, really appreciate that. I need to hop on the Discord voice chat one of these nights. And maybe we'll figure out more things to do with it. So that does it. And I think we've covered everything. We covered missing data yesterday. We covered the patterns. We talked. Oh, I know where we ended. I knew exactly where we ended. We ended right here. So let's jump back into it. Here we go. Learning again. You need to know all of this output. And if you know every bit of this output, you know everything you need to know. So let's learn it. Okay, so what's going on with this output right here? This output right here, which we do have a new thing today. We have a new thing for this. We're not going to use that new thing, but we could if we really wanted. There's the pen. Where the practice test questions be posted. Yes, it's under a channel. So Alex right there, there's a channel like practice test questions, and we need to keep posting stuff. And the more we post, like if I just use that channel, I might just go to that channel and just take questions just straight from that channel, which that's kind of my goal, because then you'll get to see when people are like, what's on the test? I'll be like, oh yeah, go to the practice test channel. Like, and especially things that I've written or things that I've like replied to are more likely. Now, if there's only like 5 questions, I might choose like 2 of them. But if there's like 100 questions, I could take like 30 of them. And then you would just be like reviewing them and understanding how it works. And so that's what I really like. Like I want as much, support for each other and as much like coming up with our own stuff and working together. So, the Discord, I just thank you guys so much. And thank you, Dennis. I can't thank you enough for your help with that. So what do we have right here? You got it. Thank you, Dennis. This needs to be read a certain way. This is a variable in the dozer data set. So how is this read right here? Who, for 20 points, 80 points max today, can read this? Who can read this? You can call it FMD, FMS. You can call this right here FMD and FMS. It's like phi model series, and it's like a dozer thing. So how is this read? How do we read this across here? How do we read this? Who's got this for 20 points? This is something we should be able to do. Who knows how to read this? Any ideas? There's a word that goes before here. Only read this part right here. 20 points right there. Given this is missing, what percent of the time is yes? Or how does it impact? What do you this would just be a table. Yeah, this is just a table of output right here. So it's just a table. Yep. Like this is it's 2 separate outputs, but this is just a table right here. This output here, and this is a vector. That's a named vector. Given FMD is missing. Yes. Anisha, I'm throwing you 40 points right there. Anisha got exactly what I wanted to hear. Given FMD is missing, how does it impact the probability of FMS missing? Exactly. Did everyone see it's given this is missing, how does it impact this missing? In terms of missing values, yep. And what do we mean by missing values? Like, we can draw our own real quick data set right here. If we draw a very little data set, like let's just call it variable A and variable B, and we can see that they have a missingness pattern. If we were to see something like, this is NA, this is NA, this is NA, this is NA, and this is NA. So now, the missingness pattern here can be seen that every time A is missing, B is also missing. So if you notice, this missingness pattern is that A and B are always missing together. So we would say here that if A is missing, B is always missing, and that is the confidence. So the confidence is if this is missing, what percent of the time is this missing? The support is what percent of the time are both missing together in the data frame. Now that would be out of the 5 rows, they're both missing together 2 out of 5 times. So the support in this little tiny data set would be 2/5 right here. So this has a support of 2/5, and it has a confidence. If the rule here is A implies B, or how does A impact B, the confidence for this would be 1.00. So the confidence is what percent of the time is B missing given A is missing. And given A is missing, B is always missing. Does that make sense? Given A is missing, for this little data set we got right here, given A is missing, B is always missing. And so we don't have to calculate this a lot of times by hand because it'll be done for us, but we should understand visually what's going on right here, that if A is missing, B is always missing. What we see right here that the support is that we have if A, excuse me, what percent of the time are A and B missing is 40% of the time. And that is there are 2 out of 5 rows right here where both A and B are missing. And they're both missing the data set 2 out of 5 times. Now, the lift is an interesting one. This is where it gets slightly complicated. The lift is the increase, and I'm going to put someone to 100 points immediately right here if anyone can tell me what the lift is here. I want you guys to take a moment. I'm going to explain to you what lift is, and I'll talk through it, and I want you to tell me what lift is. Lift will be the increase in the original probability of B missing to its new probability. Lift will be the increase in the original probability of the right-hand side, which is this right here. This is the right-hand side. It'll be the increase to this. It'll be the increase to this, given the other one is missing, from its original probability. So what is the lift of B right here? What is the lift for the rule? How much is B lifted up? So you have to know how much B was missing originally, and then you have to know how much it'll be missing now. And we covered this at the very end of class last time. This is a little bit of review. So B was missing originally 40% of the time. So this is the support of B. The support of B is 40%. So how much has B been lifted? The support for B is 40%. 100 points, who knows? Vedrana, you got it. Yes, nice job. It is Vedrana. There, sorry. And we got it. Excellent work right there. Excellent, excellent work. And yes, it is 2.5 worth 100 points right there. Excellent, excellent work. Because take a look at this. We have right here that we've increased it all the way up from 0.4 to 1.0. So it's an increase of a factor of 2.5. So what is lift? Lift right here is going to be equal to, that's one way. Yep, bingo. It's going to be the confidence divided by the support of the original. And we should, that's right there. It's just the ratio. It's just a ratio. Think of the lift as a ratio. Excellent work right there. The lift is just a ratio of how much it is increasing. Now, can lift be negative? No. Lift is a value from 0. So when we look at lift, lift is a value going all the way down here, including 0, all the way up to, I guess, as high as infinity. It'd be weird if it got that high, but it really has no upper limit. So lift could go as low as 0. And lift would be 0 that if something is missing, this other thing would never be missing. So we don't usually care about a lift of 0, especially because that means it has no missingness. So when we look at a lift of 0, we would just say, well, given this is missing, this would never be missing. It would, which might be interesting because it's like never missing then. But you could see right here, these lifts are relatively small. This data set's actually not so interesting because what does a lift of 1 mean? A lift of 1 would mean, given something is missing, the probability of this missing right here has increased by a factor of this right here. So we could actually figure out the original probability of FI model series missing, and we would just take and we do the following. So let's look at this equation. If we want to figure out the support of B, what would we do here to figure out the support of B? So even I'm having to think. Lift ratio looking at the support of the right-hand side. It's all about the right-hand side. Yep. It's all about, and I should have called that like right and left, but it's all about the support of the right-hand side. Yep. And so when we look at this right here, if you want to get the original support of B, you have to delift the confidence. So I think I have this memorized in my head because I'm thinking about the algebra and it's like breaking my head. But the support of B, so if we go to support of B equals, we want to delift the confidence. Would it be this right here? It should be. And I call this delifting the confidence. I'm like, yes, Nitin, 100 points right there. We're just going crazy with these points today. It's up to 80 until I break the rules right there for 100. And I've already done it for others too, a few others. But right here, I call it delifting the confidence. And so we're just taking this, and that should be true mathematically, right? Yeah, because you would take and you would multiply this over here, and then you'd bring this back over here and divide it. Yep, makes sense mathematically. So I call it delifting the confidence, because you have your confidence and then you're delifting it, because you can lift it when you take it and say the increase, but then if you divide by the lift, you'll get the original support. Does that make sense? Like here, up here with the confidence is what it is after we have the information, and then when we divide it by the lift, we're taking away that information and we get the original probability. Does everyone understand how this works? It's a little bit of Bayesian mathematics that we're saying, like, here is, and I hate that it does that, but here is the new probability with the information we have. Let's take away that information and we're left with the original probability. Here is the ratio of how much it's increasing. How do you know if the output is statistically similar or not? Great question. So that right there is a very, very simple code. Don't worry. It's a very simple code. The code is right here. Let's drop it in the chat. It's a big code. I've never written this code out by hand because I'll just take it and I'll copy paste it. It's in the notes too. There's the code. And so this will tell you if the rules are statistically significant. A rule being statistically significant means it's unlikely that what we're seeing here is happening by random chance. So we think there's actually some useful information right here that could possibly be leveraged. I'm not saying it could be leveraged, but knowing that something is statistically significant means that and if you can't tell, this is huge hints. Knowing that something is statistically significant means that we have possible useful information for helping us make decisions that is unlikely by random chance. And this is recorded, so you can check that back. Does that help out there, Caroline? Does that help out? Does that make sense? Are you like, yes, good, got it. Now I can, yeah, if I know, because I know what you're working on right now. But does that make sense? Is there anything else that you guys have seen in the assignment that doesn't make sense for this? There's just interpret the rules. What does the rule mean? What does this mean? And we've covered every bit of the output. Who here feels like if you've been working on this part of the assignment, you're pretty good with what we covered yesterday at the end and what we covered today at the start? You're like, okay, I think we got enough understanding. I think I know how to interpret these values. The support is how often both items in the rules are missing. Awesome. The confidence is the new probability of the right-hand side given the left-hand side is missing. And the lift is the factor increase to the original probability of the right-hand side missing. The count is how often they're both missing. So if you notice here, the support and the count, and I think there's 1,000 data points in this, because if you do 738 divided by that, you get that. So by 1,000, 738 divided by 1,000, you get the support. So the count is how often they're both missing. But that's got it. That has done it. We are good on that. Let's hop over to lecture. We're on the lecture screen. Let's do this. So now for loops. Awesome. Thank you so much, Nitin. I really appreciate everyone in the chat telling me how they feel. And please tell me how you feel if an assignment is too much, if you feel like we need to slow down. I mean, if every day everyone's like, slow down, I'll be like, But please tell me. Like I said, I get so bummed when I read a review and I feel like the person could have talked to me. I'm not mad at them, but I just want to be like, you can always talk to me. You can always tell me, hey, Brian, this is happening, or, just talk to me. I'll always try to work with students as best I can. That's my goal. And so I really appreciate you guys being, because I could kind of feel it. Because I was like, we've had activity, assignment, and you guys worked really hard. So I was like, let's just put it to Friday. Let's just do that. Let's just move it, because I could feel it. Everyone's like, is this assignment, is it due today? I was like, let's just make it due tomorrow. Let's talk about some for loops here. When it comes to for loops are used to make our lives easier. So it sounds so bad. Try passwords until we guess the correct one. Dr. Petrie made a really cool, and I think we'll do it in the activity here. But Dr. Petrie made a really cool, crack the code, guess the password activity. And so you can use a for loop to do that. And you see, here's the thing. This is why you can't enter in endless passwords into a password site, because with the speed of computers and the speed of internets, you could do something like this right here. For I in letters, and I should be able to do this. There we go. Let me try to do this. I'm going to go to letters, and there we go there. And whoops, we'll go to print letters. And actually, I'm going to do paste. And I'm going to do cat paste. Oh, my... Oh, no. Oh, my gosh. Spam risk. They know what's going on. Spam risk. I'm going to turn off the ringer for now. Sorry about that. Sorry I didn't zoom in right there. Thank you so much. The chat's like, your screen's off. And I was like, what's going on? I didn't want you to see the bad code. You didn't get to see it. You didn't see the errors I was making. There were no errors in my code. Nobody saw those errors. No errors. We write error-free code in this class. Look at that. Oh, what happened? That's so cool. Cat paste letters. Oh, I know why. Let's not use the cat then. The cat's getting mad at us right here. Okay, then let's go here. Let's call this password. And let's go here and store into password position I. No, we can't do that. We got to go to position J. And let's go to J, put in 1, and go to J, store into J plus 1. Object password not found. Got to create it. There are 26 warnings. Let's see here. Oh, I know why. There we go. Paste letters. Oh, I think I had it actually before. Let me go back. I see what I did. This is what happens when you code on the fly. Letters, position I. Now we can do this cat paste. N-A-N-A-N-A. What you doing? Letters, position I. Oh, wait. Can I not? Oh, I know what I need to do. My brain is not working this morning. There we go. There we go. So I think everything's working now, and my brain finally started to actually work. So here we go. No, what is going on? Is it in the cat? Oh, no, it needs to be in the... There we go. What is going on, everybody? Why does it not like that? Is it not? Am I doing the wrong slash? Oh, just one of those mornings where you can't remember how to code, right? You ever have those days where your brain just like, you choose all the wrong options for how to code and you're just like, wait a minute. Everything I try, it just flips it. I'm doing the wrong slashes. I can never, I get my forward and backslash every time I think about which one I'm supposed to use. I'm like, which one's the forward or back? I always have the hardest time remembering those. I don't know if anyone else has that problem. But what I'm going to do here is I'm going to construct, hopefully I can do this because I want to use the string package. So I'm going to show you guys something crazy here, which I've done before. So I'm going to make a bunch of words here. And we're going to go to string R. And the string R package has string glue, I think it is. I think I want string glue. There's string glue. And I always have to look how string glue works. String glue takes and glues together multiple strings into one string. So they show some examples down here at the bottom. And you see we have this one right here. And then we have this one, which is just a comma. Wait, where's it start? Here's the first string. They're putting their name in there. Name equals Joe. And so if you try this with string glue right here, you can see what it creates. There we go. It's nice and easy to see. My name is Joe, and my age next year is 41. Good job, Joe. And it's kind of cool because I don't use these things that often, but look, you can actually make references to variables inside of the string glue. So you could have the string glue actually take something right here and do it. And you know what? We could actually use this code right here and instantaneously put it into a for loop. So like, let's say, here, we'll go here to name equals, watch this. We'll go to names, and let's go to, there's going to be a lot. I'm wondering what it'll do now if we do name right here. Let's go to name. I'm very interested in this because it might not even need a for loop. Brian Darren. Concatenate 38, 39. What will this do? It'll probably do it. That's awesome. Could you use the C instead of the string glue? You might, well, what I want to do, and I might not do this full example because I'll just be coding a crazy for loop here, but this, I'm amazed at things that certain things code can do, because now this printed off multiple sentences right here using the string glue instantaneously, and it solves the equations inside of here, because this calls code right here. So inside of this right here, it's calling code. It's calling an object in the global environment. Remember, we use the curly brackets, or I'll type them in the chat, but the curly brackets right here use code. So that's calling an object in the global environment. So within the string glue, we're reaching out to the global environment, which is awesome. And so this right here with the concatenate, we might be able to, the concatenate won't print to the screen though. Toss, really good question. Toss, 20 points right there. The concatenate won't reach to the screen. What I'd really like to do is I'd like to nest this for loop, which I've done before. So we could nest this for loop, and we'd have here another for loop right here where we enter in and we do another variable. And I think I can do this. It might just, we'll try this. So we'll paste right here I, then we'll paste J, and maybe it'll work. And then we'll go here to sep equals this. And now we'll go to J in letters. There we go. Cool. And now you can do it again. This is going to get insane right here. We're going to take this code right here. And now we'll just go to K, H-I-J-K. And now we have literally made every three-letter, letters. It's capital letters. But we literally just made every three-letter word, which we should have. There's 26 letters. So we should have a vector of length 1757, and we could probably take, I've never tried this. Did that? It didn't store a vector. Maybe it did. We didn't look global environment. Vector null empty, that's what I thought. We have to go here, and we need to go to vector. And let's go and store into position JKL. And then when we leave outside of here, this will go into L plus 1. And then we go here to L1. And there we go. Oh, L is that. That's good. And vector. Did I not sort of vector? Oh, it's a cat. Haha, cat prints to the screen. It might have worked before. Cat prints things to the screen, so we can't use cat. And yeah, and it's having a hard time viewing it, but vector. Okay, someone pick a spot. Someone pick a spot. What password are we going to try? I like that this can just generate every single possible word. If you look at the length of the vector, oh, because L is that, and then the vector is length that. 2, 3, 4, 5. Oh my gosh. The password is DME. And it's got the \n in here now, so we want to remove that because it's not using that. So we can remove that off. And now we can see it should be DME still. So this right here is the password we've selected. Here, I'll pick one. I'm scared. I don't know what three-letter words we're going to get. This is totally random. There we go. It's just totally random. I mean, if you could figure out the pattern. But this is every possible three-letter combination generated. And just imagine, I mean, think about how quickly you can generate all three-letter combinations. It doesn't take any time at all. So we're able to loop through, and this is a nested for loop. And this is where we're going to get to in our class. In 320, they do just regular for loops. In our class, we're doing nested for loops. Has anyone here ever wrote a for loop? Like maybe did in 320, or has anyone used a for loop outside this class? Can you zoom in a little bit? Yeah, let me, just so you can see the code again, I'll go back and zoom in. Don't worry, going back. So here's the code, just so anyone can see. Remember, I post these files later. One time, Adam, yeah, if you're using for loops, then the importance of using for loops, and I might keep it zoomed in at this level like this. But for loops are very, very, very powerful. Like, what has anyone used a for loop for? Like, if you've used a for loops are amazing, but I hated them at first. Yes, Scott. Like, and once you know how to write them, they're not that bad. You just have to write the logic. If you notice, one of the first things I was trying to write was this. And once I did this, I was able to nest it inside of for loops. What is the sep function? It controls the separation. So if you do this, now the words down here will be separated by multiple spaces. So you see this right here. This controls this right here. And the sep argument will control what is the separator between all the things. So every time it has a separation, and so what did I put the sep to? Nothing, because I want there to be no, like nothing separating it. So now when it does it, there's no separation. So it just controls the separation between different objects. 20 points, Jordan. Great question. Always ask, like, what is that sep right there? What is that doing? It's controlling the separation between all the things we paste together. So paste these things together and then control the separation. And I didn't have to use the string glue, which I've used before. It's been very helpful. And then it's kind of got its own ability to do multiple things, which is, I don't know. There's so many cool things you can do. So much to learn. Awesome stuff. Let's happen. Okay. So another example I really like with for loops, and I love working with students. There's so many students, and I should stop, like, I don't know, because I got a lot on my plate, but so I'm always like, because number one comes teaching. Like number one comes Chelsea. Number two comes teaching. And so when it comes down to work, I always do my work for my classes first. Like I always get everything graded, get everything test written. I respond to your guys' emails, and then I work with other students. Like I work with, like working on some medical stuff, working on some stock stuff, worked on some baseball stuff. So, whenever students want help with certain kinds of data, I try to help out. And then there's only so much time in a day. And students are pretty understanding about that, because sometimes, especially if it's a bigger thing, and, like I'm just doing the work to help out because I like it and I want them to do well, and I want to use my abilities to help them out. So it's kind of cool getting to see some other stuff, like whether it be baseball, medical, or stocks, like helping them out. So I really like that. So I get to learn something too. So what is the whole point of writing a for loop? It's to save time. The whole point in writing a for loop is to save time. So we have to understand the basic structure of a for loop. And the most important thing when writing a for loop will be the structure we give to it. We're going to have a thing inside of it called a skeleton. You'll just see me doing this a lot. Like when I'm talking about a for loop, I'll keep doing this. And where's that skeleton at? It's the inner part of the for loop. Do you see the skeleton for this for loop right here? See, it's so easy to see in the small screen right here. Does this still, should I zoom in one more, or do you guys think this is okay? Because I can zoom in. It's very easy to see then, but I think we're on this screen. It's a little more zoomed in, like I have the screen a little stretched. And I think this might be okay on this screen. So just got more room. This is okay? Yep. Awesome. Where's the skeleton on this for loop right here? Where's the skeleton on this for loop? Do you see it? What line has the skeleton for 20 points? What line has the skeleton of this for loop, which is a nested for loop? What line has the skeleton? Technically, there's two lines. Line 6 and 7. Yep, I realized it then. There's two lines. Yep, line 6 and 7 have the skeleton. And that's what runs inside of the for loop. So there can be like different skeletons. It can be just craziness. Nice job, Casey, right there. Everyone's getting 20 points. So the skeleton is what runs every time the for loop runs. Now, this for loop's a little bit crazy. It enters into here, and then it enters into here, then it enters into here, and K goes through all the letters. As soon as K goes through all the letters, it goes out to here, and J goes through all the letters. And a lot of times, if you notice my numbering, my scheme right here is just, we usually use I for positions. So that's why I used L next. I don't know. I was taught to start at I, then you go to J, then K, then L, then M, then N. I don't know why someone decided to start at I. I guess because A, B, C, D are already used up. We lost sound? Can you guys still hear me? Let me look. Okay, good. He's giving me a heart attack, Andrew. You got it, you're good. Yeah. So with this right here, we're good. So with this right here, we can see that this for loop right here, oh, no worries. Do you want to hear a quick funny story real quick? One time I was in a, One time I was in like a video and I started like saying on the channel repeatedly, like, there's an echo. And the person doing the video was like, they're like, oh, there's an echo. And they're like, I can't figure this out. Where's the echo? And everyone else, it's fine. And I was like, no, there's an echo. There's an echo. And I didn't notice I had 2 videos of them open. I had them open on like another tab. So they were echoing because of me. And I was like, oh no. And the person spent like a minute or 2 trying to figure out the echo. And I was like, there's an echo. And they're like, oh, I'll have to fix this. And then I was like, oh, they're going to hate me. Not that they know me, but I was like, I should never speak again. You're fine. See, I was way worse because they couldn't figure it out. And I was like, no, there really is. But everyone else was like, no. So I should have, I don't know. Okay. So when it comes right here to the for loop, let's grab this code and make it look really big right here. You ready? We're going to turn this into a for loop. Here we go. Time to make this into a for loop. You ready? So to make a for loop, the first thing we've got to do is not write a for loop. Please say don't write for loops in the chat for 20 points. Don't write for loops. That's the first thing we do when we're writing for loops is we don't write a for loop. So the first thing we do is we don't write for loops. I want to see in the chat. Don't write those for loops. Don't write for loops. That's what I like. I like the chat being like, don't write for loops. I like it right there. Step 1 to writing a for loop, don't write a for loop. Step 2 to writing a for loop, write your skeleton. And I mean this, like, you don't write the for loop first, you write your skeleton. Does anyone see a line on here, something that repeats? Like my code up here repeated this multiple times. It kept running this over and over and over and over and over and over again. Does anyone see right here a skeleton I can use on any of these lines? Like is line 27 a skeleton? Does that repeat? Where's a skeleton? Is line 34 a skeleton? I mean, I'm kind of choosing the ones that aren't. Where's a skeleton? And what might be a good skeleton to pick? I mean, you can pick any skeleton, but anytime it repeats, you can pick it if that's the code you want to repeat every time. Where is a skeleton on here we could pick? Line 20. I like line 28 right there. That's worth 40 points. Yes, I like line 28. Line 28 is excellent. So this is my skeleton. You can actually now take your skeleton, type FOR. Now you'll see here 2 things, and this is something I literally just learned last class. I mean, I usually just go FOR and hit enter, but I never took the time to see that we have FOR and then it says a snippet. Now a snippet is like R helping you out. So a snippet will fill in part of the structure for you. So we have other snippets you've probably seen me use like function. So when you type FUN, that is a function because F is for friends who do stuff together. And what friends do is they make functions. So it writes out everything you need already in the snippet. A snippet is just giving you the format. There's another time we can do a snippet right here, while. You'll see there's a while function, which this is the while function, and then there's a while snippet, which writes it out for you. It just kind of creates the structure for you. So use the snippets. They're really good. Use type FOR, and now we're writing our for loop. So now we have to know what these things are. Everything inside of here is the what. Chat, tell me. First person gets 100 points. You're getting over extra credit today. Everyone else gets 20. Everything inside of there is the what. There's 2 answers I'll accept. Skeleton, toss, awesome job. And the skeleton is the code that will run. So I thought people and everyone else was getting 20. Toss getting 100 right there. Excellent work. So everything inside of there is the code that will run, and it's the skeleton. So it's just going to run repeatedly. Now this right here, this is the looping variable. So this is the variable that will change. So it can be called the body, like the body of the for loop. I call it the skeleton. It's like the inner part of it. It's like the inside of the for loop, which if you look, this is the inside. This is kind of like the control panel for it. It's like the thing that controls what it does. So we have here a variable and we have here a vector. So we have to know 100% what a variable is. A variable is just the object in the for loop that will change every time the for loop runs. A variable is the object in the for loop that will change every time the for loop runs. The variable is the object in the for loop that will change every time the for loop runs. Make sure you know that, because it's just what will change. And it can have any name. It can be anything. You can call it whatever you want. Now, a lot of times you'll call it things like I, because that's just a placeholder. But it can be, you can just call it Brian. You can call it whatever you want. So that right there is just what will change. Now, this would not be fun to deal with. That's not going to be fun. Nitin right there, 20 points. I like that in the chat. So I don't really want to call it that. I want to call it something like I. That makes a lot more sense. So whenever this code runs right here, what's going to happen? I will change every time it runs. But now what do you think the vector is? The vector are the elements that I will change through every time the code runs. The vector are the elements that I will change through every time it runs. Once again, the vector are the elements that I will change through every time the code runs. So think what happens here. The first time this code runs, it'll use the first element. Kind of like my code up here, the first time it ran, it used A, and then it went to B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, and then it changed here and did the next ones. So the vector are the elements that will change through every time the code runs. Bingo. And so what do we want to do here? So I'm going to call this I. Does everyone see how this has become I? Does that make sense? Does everyone see what I've done with this skeleton? Please tell me what 2 should become. Do you see? I love that it highlights it. So you see, the first time it runs, I'm going to call this I. So what should 2 be? If this was I, then what should 2 be? Nice job, Toss. 20 points again. Excellent work. And also Nitin right there. Who else? 2 more people. 2 more people answering. Who's got it? Oh, Sarah, great job. And Yaji, great job. Excellent work. Awesome. Let's do it. Now we're almost done. We've almost written this for loop. What vector of numbers will this go through? We are going so much faster in 320, and please slow me down if I'm going too quickly. But it's this practice you need to see, like, okay, wait a minute. I want this to go through what vector of numbers now? 20 points, everyone just answered. 1 through 6. How do we write that in code? Yep. Excellent work. And so why not 2i? Well, because you could. Great. Caroline. 20 points, Caroline. The first time, this will work. So we could do 2i, and then that would work. But then the next time it runs, I would become 2, and then this would become what? Then if you did this, the next time the code runs, what would this solve to right here? This would go to x position what? If we use this format right here, this would go to x position what the second time it runs, because it would do 1 the first time. Yep, does that make sense? So the first time it would be correct because it would store into position 2, but then the next time it's stored into position 4, then position 6, then position 8. So we don't want it to do that. We just want to do, because it, you notice it doesn't go to, if it was this structure, we would do this. So if for some reason you were like overwriting a vector, then your code right now works perfectly for this. So great job, Caroline. I'm throwing Caroline Caroline, you're at 100 points. Really great questions today. Like, why can't we just use this right here? And Sarah, another 20 points right there. You're right. That would work right here. So you could concatenate. That works. It's just a little extra on it, which is fine. And you could do this. All of these codes right here would solve this. Now we'll revert this one back up here because we don't want it to do that. And right here, you could also, let's look at this. So I plus 1. How about this right here? Could I use this? What would this become and what would these become? So if you're following along, could I use I going through 2 through 7? And then what would this become? Like, what would this whole thing? I can, not right now, but I can. 20 points right there. I can, but not right now though. What do I need to change if this was I 2 through 7? What do I need to change? I'm on the things I need to change. Think about the first time the code runs. Remember, the first time it runs, it needs to be equal to this. So it's going to replace I with 2 the first time it runs. Not 2i, close. 20 points right there. Great job. Close. Because remember, that will solve to it, but not quite. No one said it yet. This is a 200-point question. Here, rewrite my code in the chat, and who can get it? I think people are basically saying it. Rewrite my code in the chat, and first person gets 200 points. Crazy points right here. Who knows? Rewrite the code in the chat. I want you to take that code, rewrite it. I think we got it. Nice job, Nitin. Excellent job, Nitin. Yep. And Sarah, 100 points. Nitin, 200. Excellent job right there. Excellent job. And that does it. Great work. If you see it, you're seeing it. Because now the first time it runs, I becomes 2. And, oh, it takes away the arrow. Sorry. There we go. It's an equals. That works. Equals is fine. I like arrows. And that works. So seeing these small differences right here and seeing how they work is very important. This just takes practice. It takes so much practice. If you want to write, here's what I want you to do. I'm offering another 200 points. I want someone to write a for loop that just prints their name 10 times and then copy paste it into the chat. Write a for loop that just prints your name 10 times. Try doing that right now. Write a for loop that just prints your name 10 times. I'm going to set the timer. We're going to go to a speed run right here. We haven't done a speed run in a while. Let's see. Let me pull up the speed run timer thing. So who can write the for loop? We'll start the clock on it. Let's see how long it takes. Oh, you already did it. Speed run over. Oh my gosh. I think we got it. Oh, you need a little bit more. Nitin, excellent work. Oh my gosh. That was awesome. So let's see right here. That was a super speed run. Let's take a look at the code. There you go. Yep. If you're getting it, and just try copy pasting this code. Excellent work, everyone. Try copy pasting the code. What's interesting about this, and you notice this is the code that's repeating. And then, so we see here the inner part of the skeleton. There's actually no, we're actually not using I. I goes unused, which is all right. You could say print Nitin I, and then you can see here, oh, we'll go to paste. I think it will paste these now. And now we can see, oh, did it not paste? Where's not paste? Paste? We'll go cat paste. That'll print it to screen. There we go. Now it looks all... And that's what we do here. We go after this, and we go backslash, wait, we go quote backslash n. There we go. So there's the code now, and the code now prints the name with the number after it each time. So just depending on what you want, depending on how you want your code to work, now it actually shows us the number after each name. So it does this right here. We could change the sep right here, and that sep equals quote, and now it does that. So once again, and let me drop this code in the chat right here. I think it takes away the left arrow for some reason, but there's that code right there, and I've just made some adjustments to it to do what I want it to do. The cat prints to the screen, so you can't capture that, and I think that was the issue with what I first did. But look at how we can expand upon what we've done to get it to do different things. How we could add in here that it actually uses I. Now, this will run 10 times. We could change it to 100 times, just like this. Change it to 1,000 times, just like this. So nice and easy, really quick, really easy to change how many times a for loop runs. Thank you guys and gals. Excellent, excellent work right here. Let's hop to the lecture. So, why do we write a for loop? Well, once again, it goes back to people like Kenny. Kenny wanted to go to websites for baseball players on like the MLB site, and he wanted to download all of their stats, and then he wanted to merge them into data sets. So he wanted to row bind all these data sets. Actually, would it be column bind? Let me think here. No row binding. He'd be row binding them because it's different players. So he's just getting multiple seasons for players, and he's binding the rows together. So with this right here, I second guessed myself, and I shouldn't have. So with this right here, he has a task to download every baseball player. With a for loop, how many baseball players does he have to write code to download for? So he's got like 20,000 baseball players or something like that, like thousands and thousands of baseball players. If he writes a for loop, how many baseball players does he have to download for to be able to use this for loop? So it's on a website that has the same structure for all players. How many does he have to download? 1. Toss, you're right. Once he gets his code to work on 1, so he's creating his what there. Toss 20 points. He's creating his what when he gets it to download for 1 baseball player. He gets it to work for 1 baseball player. He's now created his what. Like once it works on 1 baseball player, his skeleton, Sarah, 20 points. That's what the skeleton is. You should know what the skeleton is. It's like the code we're going to use repeatedly. It's the code we just use multiple times. We're just getting the code to run endlessly here. So all he would do is go like, you think about his code theoretically, his code would look something like this. Let's just kind of lightly draw it out. Don't worry. I know. Oh, there we go. So his code, we're going to go smaller. There we go. This is good for this size screen. I've clicked those buttons 1,000 times. I was second guess. So he'd go like for 1 in player, if we knew how to spell player. And he'd go like 1 through n row players or something like this. So, or like maybe has a like player list or something like that. And that would be, maybe he has a list of players. He knows how many players there are, or he might just hard code this in. A lot of times we try not to hard code letters or numbers. So he might have this many players who played baseball, and then he'd have all the code. And I actually do have a lot of his code because I helped him out with it, and he was scraping websites, and R has the ability to scrape websites. You can go to a website and get data from a website, which is super awesome. You can download tables. So you can have R go out to the web, download the table, import it into R, and you could run code on that table. And if it's your site, you could upload back to the site. So you could be like, oh, let me update these figures. So you think about all these people with, with the COVID thing. Sorry. But it's statistics. And these people who are updating their sites daily are probably just updating the data frames that they're using. Like maybe they're pulling from a SQL database and they're just updating the data. They probably actually just have the data updating itself. They're probably not re-uploading. It's probably just they update the data and then the site has the code in it to run it. This is, if you're asking questions about how to do that, that's the real power of coding. And should I take, I think I have Kenny's, do you guys want to see Kenny's code right here? Do you guys want me to come back and show you the for loop Kenny and I wrote? It'll take me, let's get a vote, yes or no. We'll probably know in a second. I'll bring it to just vote in the chat, yes or no. Here, it'll be quicker. Let's see. People have already voted yes. Okay, give me 1 moment. I'll be right back. I'm gonna go grab it real quick and I'll pull it up. Right back. Oh, I can't mute myself here. Where's my black magic? There we go. Right back. Be right back, everyone. I am back. Let's do this. Okay, let's take a look right here. Everyone's checking their points. Hopefully that wasn't too long. I think it was like a minute or two. Let me hop in. Let me go grab it. I just sent it to myself in the files. And let's take a look. This is the one that I originally wrote for Kenny. He wrote some new stuff, which I've still got. And it's much, much longer. And so let me go. This is my original help to Kenny when we were looking at this together. Download. Let me make sure I get the right one over here. Whoop. What's going on? Computer, you okay? You okay? There you go. You good? You good? Okay, let's take a look. Yep, and then that. Close this off here. Yep. Let me install RVest. The new R will tell you if it has to install a package. So good. Yep, part, position, 4, blah, 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 install, tables. Okay, cool. Here we are. Let's take a look at the code right here. Let's see if we can understand a little bit about what's going on. So this is kind of, oh my gosh. Oh my gosh. This is the screen where I can remove myself. Okay. Let me make this bigger here. What is going on? There we go. So looking at this code right here, it uses a package called RVest. RVest is a package that allows you to download from the internet. So RVest is basically a web scraping package. So for those who want to learn how to web scrape, start looking into RVest. RVest is a package that lets you do web scraping. So if you look at here, we have URL. And so this is a read line. Oh, this was the college swimming. Oh, I totally forgot. This code that I helped Kenny with was a code that I worked with someone on the UT swimming team. He was taking in data for all the swimmers. So this originally started out as a project for the UT swimming team, the men's swimming team, which they're like really great. Swimming team, men and women's, like we're some of the top in the nation apparently because we're awesome. And we've got the apart right here. This is string splitting it all apart. And then it takes it all apart. It finds the positions and it gets the base URL. So this should store the base URL. Oh, it didn't. Did I break it? Oh, wait. For this. Now let's get the base URL. Boom. So my whole point of this code right here was to get the base URL. So hopefully my code is accurate. I haven't done this code in so long. But oh yeah, which apart, it's doing it and it's finding all this. And it literally is written so that somebody, and I should turn this all into a function, but somebody can just get this. Like all this code does is remove off the numbers, which we could just do right here. Like just laughing at myself for what I code. That took so much to work with the string. String works with strings, obviously. And then right here, you enter in your starting number and your finishing number, which I didn't enter in the starting number. So you enter in your starting number like 1, you enter in your finishing number like whatever you want that to be, and then you run your for loop right here, and it's actually going to go out to the web. So you actually have to put in like the web page with the URL, and this will like read the HTML, it'll take it in, it'll take in all the tables, and it'll save a table from it. So now we're pulling like certain tables with the HTML nodes, and it's looking for a table, and it's passing this through here. It's passing through the web page, it's turning it into HTML, it's taking a certain table in it, and then finally getting the last few things from the table, and it's storing all this into tables. So it's creating just tons and tons of tables here, and just multiple tables are being created using this right here. So this is what we wrote, and then Kenny expanded upon this and did it with baseball players, and he was actually like logging into sites and stuff, because you can actually have R go in and log into sites. So it's pretty crazy what Kenny did. Like I'm just like, his code is like 200 lines of stuff. Mine's only 27 lines, but this was the basis of what I was like, we need to understand RVest better. And yeah, so this right here, this for loop would allow you to run this code right here that goes to web pages as many times as you want. And you could take any number of, this one was set up for the swimmers from the college swimming results, and that's the power of for loops. So the whole point, all we had to do was write a code that goes to one web page. So this code inside of here, the whole point of it is to go to one singular web page. So this right here was written first. This is the first thing that was written, and then all we did was say, okay, now start at this website and go through this website. If you look at where I is at on here, do I have the I? I should have the I. There's the, yeah. So this I right here is connecting these strings together. So if you look what happens right here, it'll turn it into a string and it'll go to this web page right here. So whatever I is, it'll put that web page and it'll go to this URL and it'll store that URL, then it'll go to this URL and it'll just change what I is every time. There might be a way to do that. I bet there's a way. I mean, Andrew, if you want, you could do a lot of cool stuff with code. Yeah, so there might be a way to search and then grab certain search results and like to have it query on a web page. I bet there is a way to have R, because R can reach the internet. R can go out to the internet. There's, HTML nodes and all these things right here reach out to the internet. So R can go out to the internet. G Sheets goes out to the internet. So R can just go and probably look something up. Could you drop that scraping code into Canvas Discord? Yeah, let me do that. I'll post this to our thing. So I'll post this toss. So I think this has everything that can be posted. I'll post the scraping code. I think everything here is, yeah, it's just college swimming results. I don't think that's anything bad to post. Like it's nothing, no passwords or anything or things that you, like sometimes you have to put in passwords in these things. Like if you're logging into something, it'll actually do, you have to then have R tell it the password and you have to set up like certain permissions and stuff like that. It's pretty crazy. Like the amount of stuff you can do with R, it's just mind blowing. And it all starts with knowing how to write a for loop. Like it all starts with that. So literally the very start of this here with the for loop is what we need to know. Why are we writing a for loop? To save ourselves time. We don't have the time to go to every single web page. I mean, someone would be like, I've got a year, and be like, well, I don't want to spend a year doing this. I've heard stories. I heard stories of a guy who worked for a government job, and then he wrote code that basically, oh, who was it? I think it was Andrew Yang. I told the class wrong. Maybe someone told me that they knew their friend, but Andrew Yang on H3H3 said there was, you'd have to watch his interview, but he said there was this guy working for the government, and he went in and bots, all bots, I like that. And the guy went in and like was like, hey, I wrote this code that does everything we need to do. And they're like, wait, why'd you do that? And he's like, it makes it easier. And they're like, well, we don't want you doing that. I don't know if he got fired or what. I have to rewatch the interview, but it was Andrew Yang. I misspoke in the other class. I was like, I know I heard someone say that. I feel like it was a friend saying they knew someone, but it was Andrew Yang. It was totally my buddy. I don't know. If you know who Andrew Yang is, he's all right. But I don't want anyone to think anyway. So what do we have going on right here? We got the for loop right here. The for loop has the important parts of a looping variable, a vector of values that will go through, and here we have the skeleton. The skeleton is the utmost important part. I mean, everything is important, but this is the code we will be repeating endlessly. This is the code that we just repeat. Can't say repeat enough. We say it as many times as we want. It's all listed out here, how it works, but really the way we're going to learn how to do it is doing examples. So let's look at some of the best examples right here of how they work. Let's go and take a look. Here's a very, 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 very simple example. I'm going to ask some questions here, and let's see who can get them. So let's see if we understand what this for loop is doing. What is the for loop doing? I knew I didn't want to readjust its screen. So here comes the for loop on the screen. And it's words, hi, and there. It says for P in words, do this. The skeleton is on lines what through what? You might be right, Adam. Python is good. And I was watching a video from this lady, and she was really good at coding. I might have told you guys at the start, 12 through 20, but she was doing it in Python. Lines. So lines, technically lines 36 and 37. I would say line 35 is the control panel only. And then line 36 and 37 is the skeleton. Great job. 20 points everyone out there. You're following along. This is the skeleton right here. And then what about this code will change every time it runs? Every time this code runs, what will change in this code every time it runs? Every time this code runs, what will change in it every time it runs? So every time the code runs, what will change? P, Jordan, 20 points, great job. P will change every time it runs. Every time this code runs, wherever P is at, it'll change. So the first thing it's going to do is change to the first thing in words, let's go ahead and you can see the first thing in words is high. So literally the first time it runs, this becomes high and this becomes number of characters. And it'll save this into info and then it'll print the info. That's what it'll do. Then the next time it runs, this will become there and this will do this. It'll save this into info. No. And then it'll print info. Do you see this? I just ran it manually, but now let's go back in time and just run it normally, and there it is. Please note that with this code right here where I put high, print that. There, print that. And it's not printing there, it's printing there concatenated with the number of characters in there. So this was me running it manually. I can't highlight this stuff, can I? Oh, I can. There we go. This was me running it manually right here. This was the manual running of the for loop, and then the for loop just did it for me. And it, of course, puts them together because it's not going to have code between it. So these two things right here, this and this, are done together. And so that is a just simple for loop. And understanding the structure builds us up to the harder for loops. The loop is equivalent to writing the following sequences of commands. It's just showing us right here. This is everything I was showing you. Don't worry, it's what we just did. And right here, a loop to redefine the elements of 2, 3, and 7. So if you look right here, let's take a look at this for loop. And then we need to talk about nested for loops a good bit, because those are the complicated ones. So we can just barely see this right here. We've got x. X is a vector of these numbers. Just make sure you can talk about it like a sentence. Say, x will become the vector of these numbers. So for I, in the elements, I will go through the elements of 2, 3, 7. How many times will this for loop run? So this is a great test question. I would take this code right here and I'd say, how many times would this for loop run? Perfect test question. Be a hard thing to write on the Discord channel. How many times will this for loop run? 3 times. It'll run 3 times. The first time it runs, it'll overwrite position 2 with the value of 9. The next time it runs, it'll overwrite position 3 with the value of 11. The final time it runs, the third time, it'll overwrite position 7 with the value of 19. So let's see this in action. Let's see this happen right here. And there's 9, there's 11, and there's 19. We were able to talk through what it did by replacing the numbers inside of here, saying, well, the first time it runs, it'll overwrite position 2 with 2 times 2 plus 5. The second time it runs, because this is the second time, it'll overwrite position 3 with 2 times 3 plus 8, which is 11. I don't know how to do math. And then the final time it runs, the third time it runs, it'll overwrite position 7, because 7 goes right here. So whatever is right here will go right here and right here. Does that make sense? Little tricky. Little tricky. And I see who feels like this is making sense. You're like, okay, I got the basic for loop down, or making sense. I feel like I can write these basic ones. Maybe. Because I'll do a complicated example right here. What if I want to figure out how smart? So let's do a harder example right here, which is, I like to do a lot of things off notes, if you can't tell, because the notes are one thing. So we're going to get you there. So how about if I want to figure out you guys will hate me after this because I'll show you, oh, there's an easier way. This is very related to your assignment for for loops, which I'll probably put due on Monday night. We'll look at the timer. We'll figure it out. But what if I wanted to, figure out the GPAs of students based on their hand, what hand they use? And I don't know who's going to win this out. So let's go here and let's pull up the library, if we know how to spell it. We'll pull up library reg class, and then we'll go to data, survey 11, because we have to pull up the library because the data is in the library. We're not loading an Excel data set. We're loading a data frame that is from a library. And so now we want to use the what am I doing? Survey 11 $ handedness. Now, survey 10. Survey 10 is handedness. Survey 10. Survey 10. Survey 10. There we go. And we're going to look at people's GPAs. Okay. So we understand the data we're dealing with. We have people's handedness, and we have people's GPAs, and we want to look at the average GPA for people's handedness. So now the question becomes, well, how would we do this? Well, I want to only look at people with a certain hand. So what do I want to take to only look at people who are like left-handed or right-handed? I want to use the what to begin with. I want to use it because I only want to look at right-handed people first. So what do I use first? What might I use to only look at this group? To kind of I will use that. I will, Sarah, 20 points right there. I will use that. And maybe you might, yeah. So, but how will I only get them? Pretty much, you could use percent and percent, but I want to call everyone's on the right track. I want to call a subset. And what do I want to subset? What data frame do I want to subset? Survey 10. How do I want to subset it? These are the conditions now. Handedness equals right. And maybe that's what everyone was saying. Everyone's like, we got this. And we're just going to call this sub for subset. You can call it whatever you want. I just like calling it sub. And then we could see here, we could double check by going to like sub $ handedness, and they're all right-handed. So we have now gotten just the right-handed people. There's even a hint for something we'll need later down there. So we've gotten just the right-handed people. Now I want the mean of their GPA. So there's the mean of their GPA. And now I'm going to do something crazy right here. I'm going to go here and I'm going to call this handedness GPA. And I'm going to create this. This is a very important line right here. This creates empty vector to store into. This is a very important line. We use this quite often just to create a spot. Imagine your parents are going to go buy for you a present. Well, then they need to find a box to put the present in. This is a present, apparently. They're not just going to be like, look, new car. We put the new car in a box. I don't know. I didn't get a new car. So I thought it was like, what can you not put in a box? I was like, a new car. You can't, maybe someone does that. It'd be like, there's a box in the driveway. Then you go outside, it's just a box. You lift it up, it's like a toy car. Oh, so that's what my dad would do to me. It's like, we're not buying you a new car, son. Not happening. So here we go right here. So we got this subset being stored. Handedness equals right. These are just right-handed people. Does that make sense? This is just right-handed people. And we got the mean of just the subset. But now let's go and let's store this into, this is where your mind's going to get blown. You ready for it? Store into position right. This works because I have now created a named vector. Does everyone see I have now created a named vector where the first position is right? The second position is left. And so we could view it again. And the final position will be ambidextrous, and I dare not spell that because you can double click. Double clicking is way better than trying to spell things. Copy paste is what we do. And here we go. Here's ambidextrous, and there's all the GPAs. Ambidextrous is 1. It's the ambidextrous. I don't know. I can't use both. Ambidextrous. Andrew is part of the ambidextrous group right there. I don't know. Maybe you are. Maybe you're very proud of the ambidextrous individuals. Kind of close. We could do a statistical analysis to see if these differences are likely by random chance. We can see what the p-value is, but we do have some differences here. So with this right here, what did we just write right here? I mean, I was using it. I got everything I wanted, but what did we write? We actually just wrote our what? Remember step 1, we did step 1 by not doing it, and then we did step 2 of writing a for loop. Step 1 is don't write a for loop. Don't do the for loop first. Don't do your for loop. I wrote skeleton, Casey, 20 points right there. You're right. This is my skeleton. So guess what? That's the skeleton. Now I just need something called here, like let's say it's hand. So this is going to become hand because this is what changed. Do you remember just a moment ago when I was changing this? This is what changed. And then I said something would be very important. This. It's going to change through the levels of survey 10 handedness. So if you notice, the levels of survey 10 handedness are just that. So what do I want hand to go through? I want it to go through all these levels. And we do have everything correct now, good. And now I run this, and it'll actually put them in a different order. Can anyone tell what handedness level will come first? You can put the first letter of it, 20 points. Who's got it? What handedness level will come first with the way this ran by default? With the way this ran by default, it'll have what group first? It'll have ambidextrous, right? 20 points, Jordan, right there. Because ambidextrous is the first one it reports due to alphabetical ordering. So we run it, we show it, and ambidextrous is first. But what if I wanted right-handed first? Watch this. I can go here to levels, and I can say do the third, the second, and the first. So now it'll go right, left, ambidextrous, because that's their order. And now I've reordered them up too many dimensions. Wow, I did this in the other class also. We did a separate example, but I did the same error. I treated it as a three-dimensional object, and it should be concatenated, and you make mistakes. And now we see it's right, left, ambidextrous, because this levels vector, I can reorder the levels vector by calling the positions in any order. If you notice right here, I could just add in do right twice. Now if I run this, it'll report the third level twice, like that. That's what I'm doing right here, is I'm going to this levels vector. I'll put it on its screen by itself. I would never, you don't want to do that, but if you notice, this just lets me report certain things from it. So I can report any level I want and put them in any order I want and just rearrange or order them any way I want. And yeah, so we've done it. We've written another for loop, and we've got more than enough time to, I think, tackle even a bigger topic. Hopefully today has not felt too crazy. We just got examples of for loops, and there's lots of examples in the notes. I want to say one thing. Dr. Petrie, when he made these notes, said I put in more examples than you need to do. He kept telling me, I said, more examples than you need to do, Brian. And I was like, but I want to do them all. And he said, you can't. I said, I'll try. And then I tried, and I failed. So here's another example, and I really like this one. This one is a time series analysis, and we talked about time series yesterday. Oh, send me that, Sarah. Send me your code. You must have a, when you do this, Sarah, click your end bracket, and you should see it highlight your opening bracket. So you've probably ended your code somewhere. So click your ending bracket, and it should highlight your opening bracket. If you click like your ending bracket, and it comes up with like, you see, I click this, and when I click that bracket, it shows me it's closing it here. So your brackets must be off. You can always click a bracket, and it'll show you where that closes it, which is one of my favorite things we often forget in ours. You can click this, and it'll show you where does that close. So this closes the mean function. This closes the positions on moving average. So little tips like this are very important. Like this is the inner close of the time of what elements we're going through for demand. Does that make sense, Sarah? Did you get it fixed? 20 points, Sarah. Really great question. Like put those errors again in the chat, but that just means you've probably closed your for loop somewhere in there. Like your for loop has a, I bet I could make that error occur if I go here. Let me do this. Let me try this. I might have an open. Let me close that. It's up. Now it's running code. It's not finishing. It's saying haven't finished. Yeah, it's just getting mad. Yeah, it's that figured it. Yes. The different errors you can get are so interesting, but unexpected that means it somehow closed your code. Yep, great question. Sarah, that's where the 100 points. That's awesome. Really appreciate you asking that. Demands not found? No demands. Cool, now demands are found. So what does this code do right here? We have to know what this code does. We're going to read every bit of this as a sentence. Set seed. Anyone play Minecraft in here? Anybody play Minecraft? Where's my Minecraft people at? So I need that like meme song for Minecraft. So like so many meme songs. But this sets the randomness like your Minecraft world. There we go. People know what's up with some Minecraft. I have a really cool Minecraft world. It's on my Xbox, my 360. Oh my God, occasionally. So here we go. Sample 5 through 20 with size 50, replace equals true. So the demands right here, if you look at the demands, all they are the numbers 5 through 50, 5 through 20. I was like, those are not 5 through 50. 5 through 20 sampled 50 times with replace equals true. You'll get the error here if you do this, but it's just saying make a sample of the numbers 5 through 20, taking 50 of them, and we have to replace because that means they can repeat. If you do replace equals true, it means they can repeat. So demand is now a vector of 50 random samples of the numbers 5 through 20 where we can replace them. Please notice, the goal of code is just to treat it like a language, because coding is a language. If you read these things as a sentence, like, I am creating something called demand, which will be the numbers 5 through 20 sampled, I will take 50 of them from the numbers 5 through 20, and I can replace them. Like, I can repeat numbers, which you see down here where we see 15 and we see, well, there's 13. Where's a 15? Is there no other 15s? Oh, there it is. I was like, did I pick the one number that did not repeat in 15 numbers taken? Or that's 16 numbers, I think, right? 4. That's 16 numbers. So we could always check it. I'm 99.9% certain. You go here, you go to length, and you check, it's 16 numbers. There we go. I moved it back 4, and I thought it was 1 through 16, so I was like, okay, 16. The moving average is going to be repeated. So we've seen this. This is where we're looking at our code that we've already done. The moving average is going to be the repeated NA 50 times. So when we make this vector right here, we're just going to see a repeated NA 50 times. So we're just creating a blank space. In truth, it's probably a better way of doing it. This is probably the best way, but there's many, many ways to do this. Now look at this. We're starting at 3 through 48. Now this confuses people. The idea of a moving average is that we're going to make a window here. We're going to average together 2 days forward and 2 days backwards to see what the average was for that period. Does that make sense? When we're doing this moving average right here, we're making a windows of 2 days forwards and 2 days backwards. So what are some days in this time series of data for 50 days that we cannot get data for? 200 points, these last 2 questions. I'll pick the 2 people who only give one of the answers. There's one period of time we can't get data for, and there's another period of time if we're going 2 days backwards and 2 days forwards to make a window. Like, I'm current day. Jordan, I'll take that right there. Positions 1 and positions 2, because these are the first 2 days. We can't go back in time. Like, on day 1, you can't go back in time. Here's day 1. You can't go back in time 2 days. On day 2, you can't go back in time 2 days. Boom, Toss got the other one. Nice job right there. And Jinning, I love the way you put it right there. Jinning gets 200 because they explained the first 2 and the last 2. We can't go forward 2 days and we can't go backwards 2 days. So what you're going to see at the end result right here is we're storing into position 3, and then we'll do this equation. I mean, time will change here also. It'll take time. It'll create this window right here. If you notice, this is just a window of demands. And what is it going to do to that window of demands? It's going to find the mean for that window of demands. And then what's going to do to that mean? It's going to store that here. And then it's going to go to time position 4. And it'll make a window of demands. If you look at this vector right here, this, if you're wondering what this code does, it just creates those positions, 2 through 6, because it's 4 plus 2, 4 minus 2. And it creates a vector for us to look at it. And then we get the mean of all that, mean of the demands in those positions, because here's the square brackets. Please note those are square brackets right there denoting positions. And once we get the demands in those positions, we find the mean for those. And then once we find the mean, we store it here and we store it into position 4. But we don't need to do this. Oh, there's nothing in position 4 till I run the code. And now position 4, we'll go down here, watch this. There we go. Position 4 now has something in it. But we don't need to do this manually because that's the whole point of a for loop. So we go here, we run this, we run moving average, and there you go. Done. Just went through and did it all every time for every single thing. That's the point of a for loop. We're not going to rewrite and save over because the only thing doing is we're running this equation and storing it into a position. Would it not throw an error when you go outside the vector size? Yeah, I bet it will. Totally. Let's do it. Actually it creates NAs. Yet it because there's no data. Yeah. Yeah, let me try this. Let's do it. I think do we do the visualization on the slide? Do we? Maybe we don't. That's such a bummer. Let me do it. Here I'm letting you guys out 1 minute early. So class is over. Brian's going to try to make a cool visualization of this. So Brian's going to make a cool visualization. He's going to cheat. He's going to go to Plotly in our time plot. So we're going to go to time plot in Plotly, and this is R. So here it is right here. They've got their X, their Y object. So we should be able to make this pretty quickly for the time series of the data. And they got all different plots right here. This one's not so fancy, but we'll take it. We'll do it. So let's hop over here. Am I broadcasting on the wrong screen? No. Okay. Today is the day I just kept doing that. I'm very sorry. Okay. We're going big thing right here. Okay. So let me pull up the chat right here. Great job, everyone. Really good day today. Screen check. Thank you, Sarah. 20 points, Sarah. So, oh, he's on slide 54? Really? How off is my brain today? Oh, that's the wrong slides. Is it really? Oh, no. I think you might be, there's a bankroll example right here where we do a banking example. And, or am I using different notes than you guys? So, maybe we updated. Oh, maybe we did. I'll figure it out. So here we are. Let's go smaller. Okay. So, maybe that is too small. I don't know. You guys just keep telling me. So let's go here. This is the time series is a sequence. So we need to call this time series. And we'll just call that, that can be X. And the Y variable, okay, this is the Y variable they're analyzing. So we have here 50 data points. So the time series is going to go from time 1 to time 50. And it's going to go by this. And we don't need system date. We need to run library plotly. Moving average, do we still, let me change this back to 48. And we need to reinitialize our vector. Great job, everybody, today. Excellent work. And so now we need to, this is just going to be the time series, which is going to be X. There's that. And object TM not found. Sure. And then the Y variable is going to be the moving average. And since we literally just took the structure of something else, it might just plot for us. And it did make it. It's mad, but no, that's got it. We just did it. We could do a dot plot too. They've already got the dot plot ups for this. But, and I didn't change 28 days. Whoa, that's, oh, and it already tells you like how many days. Is that, whoa. Let's change what it says from that. So this right here, so there we go. Okay, now let's zoom in again. Okay, so if you look, you can literally look 28 days from start. And so this literally on the third day says 3 days from start, reports the day at the top and reports the moving average. So we could probably add in another thing here, which paste TM, I wonder if we could do, I've never tried this. My mind's about to be blown if this works. But I'm going to go here and go new line. I'm going to use codes we use today, new line of code. And then we're going to say moving average, comma, average. And that should, let's see, it's mad about something. What are you mad at? What's it saying? Missing argument to function call. Oh, there's 2 commas. Are you good now? Okay. Let's see if it did it. Did it do it? Yep. Look, right here we have 13.8 average. So it reports the average for us. So when people hover over this, it'll report the average and it'll report the days from start. So I might even try to remove that 40 and 112. I think it does that by default. And I think we can easily change it to dots because I think I saw something on that. But this is the kind of stuff I like. I like just playing around with this. I just saw it. And where is it? Is it mode? What was the code? Mode. So it's markers. Okay, so there's markers here. Yep. So there's that. I wonder if we can go here. And what was the other one? Lines? Oh, it didn't like that. It did not. It said no. Mode lines. Yeah, you can't do 2 modes. It's mad about that. But if you look at how easily we can change this plot right here. Oh, I know how to do it. I know what we'd need to do. This is after class right now. We're just having fun right now. We'd need to add to it another plotly. We'd have to go here and go to this. And Let me look. If I know how to do this, then I've learned a lot about Plotly. Plotly. Okay, it's add trace, I think is what it's called. Add histogram. Okay, so we should go here and go to add. Ooh, scatter. Ah! That's not gonna. Yeah, I didn't like it. All right, okay. I got the plot we wanted, but 2 colors. Do you want 2 colors? I got an idea. Can we plot these 2 lines in one plot? Jinning, are you thinking about like you're thinking about how to add in? You want the line plotted through it, and you want the dots, right? So you want the dots, and you want the lines. So wait. Or we can do the smoothing average. Okay, so Jinning, I think we got it. So what you're saying is let's take the original data values of demands. Yeah, so what we could do is we could take the original data values of demands, and so let's go here and make a plot for demands. And like, so we'll get this figured out. I really want to do this. Hey, what's up, Isaac? So good to see you here. Look, we're making graphics again. We've got some Plotly visualizations. We did it with a line. So there's a smoothing average right here, and we'll go through. And we've got this one object right here, which is already created. We can change it back to lines real quick. So good to see you, Isaac. So looking for sinusoidal patterns, you bet. That is what's going on these days. So here is the line. The code on the slide was 54 moving average. Oh, they just did the plot. Oh, they just did the plot time series. Yeah. Man, why didn't I see that? What? I'm changing the Y limbs. There we go. See, but wait, look. You got this. Oh, it's under viewer. We can do this, or we can do this. What looks better here? This or this? This? Wait, not that. This? Can't hover over it. Or this. And we could add in a title to this pretty easily. You can make a cool title. I'm gonna cheat and grab the title thing. So I know how to do it. Okay, I'm gonna do it without looking. I swear I didn't see it. We'll go to figure, layout, title equals time series of demand. And we'll remake it. There we go. I need to practice. I need to like you like this blue one better, and what I want to do is I want to put in the dots. I want to put in the original demand values of dots. So we've got here a figure, and we need to make another plot right here. We're just going to make figure 2 now, and figure 2 is going to be very similar, but figure 2, it's literally going to be so identical to it. Figure 2 is going to have, instead of the moving average, it's going to have the demand, and then we're going to use, what was it called? Oh, what was it called? I seriously just blanked on what it's called. It's called, Brian, can't remember the name of it. Okay, so scatter plots. What was that called? In R. What's the different mode is what I'm wondering. I haven't used this mode so often, so I don't know. Whoa, I'm seeing some 3D stuff. I don't want 3D scatter plots. Okay, here we go. Mode marker. Oh, it's marker, right? It's mode equals marker. Okay, so I don't want to overwrite my figure. I want to call it figure 2. This, let's remove that. And let's run this. And wait, what? Oh, ha. Fig 2. Oh, it's mad about something. It's really mad at me. Oh, here we go. This is... What is it mad about? Let's take away the text on this. I want the text gone. Oh, because of this. Didn't see else on the line. Fig 2. There we go. It's marker. Let me see what people are saying in chat. The blue one gives more accurate info. Yeah, I agree. And I'm looking at other scatter plots right here. Like, we can make our scatter plot look like this. Here's multiple scatter plots. So I think we kind of want this right here. Look, it's add trace. Oh, so add trace, da 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 da. Well, look, you can just literally take lines plus markers. So we could have just, oh, so that's how you do that. It's just, well, that was easy. So all you would do is take this right here. We'd go back to this. We'd drop this in. And now we add in the title and we run this. And there's lines plus. So here we go. If you look at how easy it was, here's lines plus markers. So this small little change right here changed it. And we could probably change the color pretty easily. It's got to be the trace. So it might just be color right here. I'm going to make this look a little bit better. We're going to go here, go there, and go here. And yeah, because that's the inner part of that. And then another argument. Let's go color and see what it does. Well, let me adjust the color. The answer is, that's not green. Blue? Why would that be green? It's mad. It's really mad about something. I think that new argument it got super mad at. I don't know why. Yeah, it was a new argument. Or it's just giving no trace specified. If you have questions, feel free to ask. We're just kind of having fun after class right now. Just, this is, this kind of stuff. Could you help me with one deal? Yeah, let's do it, Jordan. Yeah, anytime, Jordan. If you see me doing this right here, you can just ask. I'm just, of course, trying to do a time series plot, having some fun. If we got to repeat the process again, will we get, yeah. Watch this. If you went and changed, and then we'll do Jordan's question right here. If you went and moved your window, so if you were to take your window and go to like, let's say 10, and go to, so this would be 11, and this would be 39, right? And then you'd subtract 10 from this, and you'd add 10 to this. So it'll stop at 39. So you're welcome, Anisha. Great job. And now we're going to redo this data right here. And so this gets to be a much more smoothing average right here. It's going to limit our data set, but we can rerun this right here, and we can take a look at the figure. And there's a jump in the data set at the end, but it gets to be a lot smoother. So this right here is a little bit more smoothed out, but there does appear to be like a jump in the data set, which is odd that it had such a jump. But here we'll do one more smoothing, then we'll do the question right here. We'll go to 20, and then we'll go to, so we'll go to 21. 21 through 29. This should be pretty ridiculous. And this needs to be minus 20 now and plus 20. And I should just make it so it augments those by itself. I should code that in. But this should be much smoother. Let's find out. Oh, it just goes to a big peak in the middle. Oh, but also look, the degree to which it's the difference in the data, we're not actually, if you put these all on the same axis, this is the last thing I want to say on this. This one starts at, this one goes as low as 9 or 9.6, I can tell, it says me it. And this goes as high as 16, where when we went here, it's not on the same axis. If we put this from 9 to 16, so if you were to view this from 9 to 16, which you can, if you were to view this from 9 to 16, it's a lot smoother. So it's just zooming in on it. So I was tricked. I was like, yeah, it should be a lot smoother. So this is this one from 9 to 16. And then the next one, this one right here, if we view this from 9 to 16, you can tell it's going to look a lot. So yeah, look at this. Here's what this graph looks like from 9 to 16 now. It's a little bit lower, but that's fine. And so here's what it looks like now. So you were exactly right, Jinning. That's what happens in a time series when you do a longer moving average. It smooths it out. So do you want like a smoother one? Or do you want a, it all depends. It's just going to smooth out. But the reason it wasn't looking smoother is because the y-axis was changing. I was like, something's weird. Like, something's theoretically wrong. Because what you said is theoretically accurate. Like, averaging together more values will kind of blend them together and you won't see distinct values. Yeah, no. And I was confused. I was like, what's going on? Why does it look like this? And I was like, oh, the scale on the left. Because I was like, oh, it only goes from 13 to 13.7. So that's the cool thing about Plotly. It augments it for you. It kind of controls it. So let's take a look at the homework right here. Let's do this. Do we have assignment? Homework? Validation. Let's do it. Oh, I got a yawn. This is Jordan. You got it. Jordan, that's a great way to ask a question like BAS 14.4 right there. I like it. I like the way you asked that question. So let's do this. I'm going to remove this, cleaner out my environment so it's holding less memory. I'm going to put myself in my box right here. Boop, in my box. And now we're going to go to 1C. Here we go. Make a character vector called bad levels that contains the offending levels. So we need to find these offending levels. So let's load up the data. Okay, looks like we loaded it. I think this is the by data frame. So we have by 2. So with by 2, we want to look at the product name. Was it product? No, it's the name. Okay. So we've got here offending levels. So this is a previous question right now. How do we find the offending levels? It said to do something to check the what of a certain thing. Oh, I was holding the wrong thing. It said to check the what, Jordan. We're going to check the what of the name to figure out, because it said it's in a certain spot. We found it. I think you can use by 1. I think they're basically the same. I think they're literally identical. I've always wondered that about that, but I don't think there's any difference. So you can use by. There you go. And if you notice, it's the same output. Is it the same? I think it is. My brain's breaking. Oh, 1D. We'll do 1D next. Yep. And we can. So here, for those wondering, the bad level, and I guess we need to go to levels, really. We could do levels of head of levels. So it wasn't the same for 1B. Yeah, I think, oh, it wasn't. Oh, then be careful. Does everyone see this 404 not found right here? So it should be by. Does everyone see this 404 not found? Has anyone ever seen 404 not found? That's when you go to a web page and it can't find the web page. So what this happened is they went to get the data and the data wasn't there. So these are names of notebooks. Don't worry, be like, is there this? Is there this? These are actual names of notebooks. But the 404 not found is not a name of a notebook. So what we want to do is we want to go here and go bad levels. And we want to store into it this. And then write a command that prints out the total number of values in the name column, which are bad. Another command that prints out the fraction of values in the name column that are bad. So now we want to know in the names. So we want to go names. Actually, I can't even. The print out the total number of values in the name column that are bad. Okay, cool. So we want to go to by $name, and we want to go to. You can do it either way because this is a vector of 1, and you go to bad levels, and this will give us trues and falses. Don't print that to the screen. That's too much output. And then we want to know the total, and that's the total. And we want to know the fraction. We'll do it the quick way. Copy, paste, paste. And you go here. And I think that's what it wants. There's the total, and there's the fraction of bad levels. So that's the total bad levels and the fraction of bad levels right there. Now for 1D, the table command produces a vector of integers that give the frequency of all its unique values. Much like each column in a data frame, its name is given. Each element in the vector output a table. This question's put me to sleep. Oh no. Sorry, guys, just making jokes. These names can be extracted as a character vector with the names. Yeah, names command. Thus develop a command that uses which and table and names, and that prints to the screen the names of the two products that appear 281 times in the data table. Okay, so we know the things we're looking for appear 281 times. We also know we should make a table. So we know we should make a table, and we should look inside of that table for things that are 288. So Jordan, did you get a different result for, wait, sorry, I just saw that. Those both the same there. What result did you get, Jordan, or what code did you run? I get worried when there's a different result. Let's go back to 1C for a second. Make a character vector called bad levels to contain the offending levels, then write in a command that prints out the total numbers of values in the name column, which are bad. And then, yeah, if you put your code, Jordan, I can analyze and figure out what's going on. And then we'll fix it up here. Thank you for staying around, Jordan. Thank you for asking questions. I'm sure other people might be watching this video later. And hopefully I haven't said something wrong. I am capable of getting things wrong. Prints out the I think these are accurate, though. But bad levels as character. It looks like you have... This looks to be a lot. And here we'll find out. It looks to be... Here, let me break down what's going on right here. What does this create? Maybe I'm missing something, but this isn't... Oh, this is the second line of code. What am I doing? What am I doing? As character, and then you're taking... Okay, let me see here from the start. You're seeing if this is equal to this. This is a logical test. This will return trues and falses. So where am I... Oh, I grabbed one extra parentheses. And yeah, thank you so much for leading the code too. Yeah, no worries. Yeah, I appreciate it. And then we're going to which, and we're finding it. And then you're going to the positions of these right here, and you're returning the what's in those positions, the names. So I think I see the, and then what you've done right here might work. This might work. You would just have to take, after you create bad levels, what's his non-liking about, oh, it's seeing this as 2 lines, that's why. And this should be a second line, got it. That's why it wasn't running. And so if you were to take and run my line of code here, it still works. So we only, what you have, it works, but we only need the name of one of them since the name repeats. What you've created right now is, did not create it? Did you just create the name? Well, I'll be. I thought, wait a minute. I thought it created the full, and then when you do as.character, it turns that all into characters. And then when you store it into bad levels, shouldn't it store this? Yeah, it does. What am I doing? What happened? So down here, this is this. Oh, you called it bad dot levels. Oh, it's the period right there. So now, maybe it asked us to call it that. Yeah, your code still works with these right here. It's just that you're checking a ton of things. I thought it would work. And then this right here, this is where the issue is. Okay, unexpected. Oh, you have the 2 things. Okay, so wait. Okay, this is accurate right here because this is how many of them have bad levels. This is accurate. And then this is so close to accurate. This right here just needs to be this. And that is that. There you go. Jordan, great job. Jordan, I'm throwing you 100 office hour points. Thanks for posting that in here because I know, and you did that all on your own, and you almost had it perfect. Like, it was just one little thing right here. No, thank you. I appreciate it. You just have to get stuck, and you have to be like, hey, mine's not doing it. And you don't want the names of the length vector, or you don't want the length of the names vector, because this is the length of everything people reported. But the names of the length vector is the length of how many types of, whoops, what I do, names of length, wait, what? My brain's just broken. Names, can we do names of by, $? Name, the names vector is gone for that? I guess, what did your code say again? Levels. See, Jordan, even because it's not names, it's levels. It's a categorical variable. So it's levels. The levels, I was thinking of data frames with names. So the levels are the levels of a categorical variable because we're inside of a categorical variable. You had levels there? Yep. And my brain just broke because I'm like, what are the names of the levels? So I was like, what are the names of the levels? And I'm like, oh, it's, to get the levels, we get levels. And I was just using this earlier. If anyone was wondering, Dr. Petrie, please let me teach the class still. Where's my 474 code from today? I swear. Dr. Petrie's watching this, and he's like, Brian doesn't know about levels. We will go to the 320 code. Where's my 320 code for today? Look, Dr. Petrie, where did I do it? I did it right here. I did levels. I know the levels function. It's so easy to mix stuff up. You've probably experienced this, Jordan. You know that with coding, it's just about you get things wrong. It happens. So we want the ones right here. Let's do this. Let's make a table. Watch this. We're going to get this one right away. We're going to go to a table, not a table, but table. And let's make a table of this right here. And we're going to make a table of the names. And we see certain amounts. But I want to find certain things. So I want to find things that are equal to this. So guess what I'm going to write right here? What am I going to write right after this, Jordan? I want to find certain things that are equal to that. I know you know it. I know you got this. I want to find certain things that are equal to that. What do I want to write right there? I want to find certain... Well, no, you're on the right track. We'll do that next. I want to find... Yeah, Sarah, you got it. There we go. And then, yep, and then this. Now, this will return back. Now, before you run it, think what it'll return. Trues and falses, because this is a logical check. Now that we have trues and falses, I want to turn those into positions. So now I want to turn these into positions, right? So now, Jordan, how do I turn these into positions? There's your hint. How do I turn these into positions? Now you see it. And Sarah, 100 points for being here. Extra bonus office hours. And Sarah knows the answer. You got it right, Sarah. So now these are the positions. So now this doesn't mean there's 153. It means, and we'll take a look at that. Alex, we got it. I think so. Here, Alex, we got that next. You got it. And then now I just want the names of this. Because the 153 doesn't mean there's 153 of this notebook sold. It means the notebook with 281 was in position 153. And we go right here. We do this. And those are the names. And we could confirm by going to the buy data frame and looking at position 153. So we're going to go all the way down here. I should do what I did last night because I was working with data and I was doing it a much better way. And this is position 153. It's this second row right here. And we should see 281, wherever that is. Am I losing my mind? I probably am. What was it called? It was like, what did we make a tab of? Oh, how many times it appeared? Oh yeah, we can't look at that then. It's not, it's 153 in the names vector, which we'd have to do this. So we have to go here. And let's go DF. And then let's go to position 153. And then it was positions 153 and I think 155 maybe? Yep. And then we have to go here and we have to concatenate 153, 155. And then there's the two positions. Now don't add in this extra stuff. Don't add it in. Let me grab Alex's code right here. Why are we using EX2 tips for the data? Oh, I think we just did it for fun, right? In class today, you worked through the statement about, and let me show the code here in case people are copying it. Dan, you don't need that. You don't need this. That's superfluous code. In class, you're welcome, Jordan. Keep asking questions. Just be like, I'm sure people will be very happy with more questions asked. Even if you want me just to explain a question you may be done. Like, I'm totally good with that. Got tons of times. Why is the EX... Oh, cool. Good question. Okay, now I understand even better. Thank you, Alex. 100 points for showing up to office hours today. I like it when people show up here and we ask lots of questions. What it is the EX2 stands for example 2. This is how Dr. Petrie called things inside of reg class. EX2 stands for like example 2, like it's a group of examples from like a chapter, like examples from chapter 5, examples from chapter 6, examples from chapter 7. There's no chapter 8. Examples from, there's chapter 9. There's no chapter 8 examples. You're on your own for chapter 8. There's no chapter 1 examples either. That's like the introduction. But these are examples used in chapter 2, 3, 4, 5, 6, 7. Oh, there, it does a partial match. Yay! And then no 8, 9, and there's no 10 to the book. But does that make more sense why it's EX? We're calling data frames, and data frames can have any name like empty cars. Here's just a bunch of different data frames where you have crime tab. What is crime tab? Let's find out. So crime tab is this. I don't know what it is. That's a big data set, and I wish it was more descriptive. Yeah, good job. I speedrun the assignments. I love that. Great job right there. Noodles. What is this? Would this work for 1D? Let me see. Let me see. Will it? It looks like it might. Noodles, tables, by... Which noodles? Wait, but the noodles right here is being referenced. Oh, do you have... The only thing I see is this noodles right here. This should be... Oh, you're doing which... Oh, God, wait. It's a different line. Oh, my God. Yeah, I saw it. I know, I realized it. Then all you need, do this. And then do this. Now, here's the thing. If someone... Don't write down noodles if you're watching this. These are not your noodles. So this reports this, and this reports this. So you can see, great job, excellent work, Sarah. And that's what I like is when people are like, is this doing what I want? Now it's reporting just the names right here. So you can do it in 3 lines like that, perfectly fine. It's all just how you want to code. Here's the thing in 1 line, and here's it broken apart. We're restoring the object. We get the table, we take the which of the table, and then we take the names of the table. So all you need to do from there is take the names of the table. I mean, technically, this is still the answer. Like, that's still the names right there, but then it wants you to just get the names off of it so we can just report the names. Because especially if we handed this to someone, they might be like, wait, what does the 153 mean? And like, that is the 153rd item in the table. So it's reporting for us the position of the trues. Is there a function for does not include in R? Something like, yes, Jordan, amazing question, Jordan. If you want does not include, do this. Let's say we want to pick from a vector things that are not, like we're going to go here to survey 11. Here's the code you need to write. Library, reg class. So that loads reg class. Remember to install reg class. I gotta stop yawning. Survey 10. Survey 10 is handedness. Okay, cool. There we go. Here's the handedness right here. And maybe I want people who are right-handed, but this is not what you said. So there's the right-handed people, but maybe you want things that are not right-handed. So what you can do is take everything here and do that. Now everything has been flipped. So if you want to flip a percent and percent for not these, the percent and percent means everything here that is contained over here, and then everything that is not contained by putting the exclamation mark on the outside of it. Like you evaluate it, I put it inside of a parenthesis to evaluate it, and then I just put a exclamation mark on the outside of it to just flip everything. Because now it's like, here's the things that are this, here's the things that are not this. And you could do a multiple thing. You could do like concatenate left and right. So now I'm only going to find my my ambidextrous people. So these are the people who are ambidextrous. We could put here a which around this. And so that's the which. And those are the ambidextrous people. We could call these A and B. And then we could go here to handedness. All right, survey 10. And we could go to the handedness vector. And we could report the A and B individuals. And they're all ambidextrous. What's up? Good to see you, Hermona. So good to see you. Hope you're having a great day. Miss you from mini-term. Oh, I love it when the mini-term. Oh, I was talking about mini-term this morning. We're talking about some Stat Nation. I gotta talk more about Stat Nation. Like, oh, I miss you guys from mini-term. So good to see you. And I really want to I tell you, I was telling my fiance, I miss seeing students. I see you guys here, but I miss seeing you guys on campus. I miss people coming to my office. We got candy in my office. Let's do 6C. And we'll work on, we'll figure out what's going on with my office. We'll figure out what's going on with the world and campus and stuff. Still wait. I know, Mona, right? That's awesome, Mona. We need to do that. And we've talked about someone in our classes, what I want is I want us to sell a shirt for $10, and we'll go into 6C here. I want us to sell a shirt, I can't speak, for $10, and we got 5E also, it looks like. I want to sell a shirt for $10, and all proceeds from the shirt would just go to tutoring and stuff like that. It'd be a pretty nice shirt. It'd just be like a Heather shirt that said Stat Nation. It would just say Stat Nation. Gray Heather, and then orange Stat Nation on it. So, who was it? It was Ahmed. Ahmed was saying, I think he's the one who can do shirts. And he's like, I'll make it or something. I'm just everyone's willing to help out. But yeah, I'm pretty sure I'll have to talk to him about that again. And I think he's gonna enjoy that. But 6C. But no, we even have do you ever use Discord, Mona? We have a Discord now. One of our students. I'm all for it. Awesome. Anytime, swing by anytime, Mona, say hey, and we'll try to get the Stat Nation shirt going. And once again, all proceeds from it will go. Discord is an app you can use on your phone or your computer. And we've got a Discord now for 201-320-474, thanks to Dennis. He made it. So we're, it's just like a chatting app, and we're going to use it to help students. So really cool stuff, and students helping us build things. I'm really appreciative, and I love you guys' positivity and help for each other, because that's what it's all about. That's what I care about. Awesome. Let's see here. 6C, make sure the reference to the overall fraction of the rows missing low. How do we determine that from the table? Got it. Yep. Okay, here we go. So much stuff, so much output. Okay. So the overall fraction of rows missing low, we should be able to, I'm going to insert a chunk right here, and I didn't show this in class. There's a lot of ways to figure this out, but we can go here to item frequency. This is in the notes, but I'm going to show another way that I did today to figure this out. We probably called this rules because we always call it rules. Oh, is it man? Didn't we do it up here? Inspect, list, dim, list support. What's it meant about? Make rules. Oh, okay, wait. I've totally like destroyed the code from yesterday, I think. Okay, I think my code is all broken. Yeah, dude, check that out. Jordan, definitely check that out. I'm going to download the assignment again because I think I've broken it with what the code I wrote yesterday and I don't want to fix it. It'll take me more time to fix the code than it will for us to just do it. For me to go back into the assignment, which I'm almost to, and I'm just going to re-download the assignment, and that way we can talk about how to do it and what it means. So here we go. Let's do this. Okay, so we're opening back up the assignment right here, and we're going to do the quick way down to it. We're going to go 6C. We're going to run all chunks above. We're going to run the current chunk. And then we do have item frequency. It was transactions. That's what it was called. And here's the answer right here. So it is in the code right here. And let's talk about what this is. And then let's show how to get it from what we did today. So right here, Vedrana, we have the item frequency. And the item frequency for low is the following. This is the support for low. This is the support for low right here. That is literally the support for low. Now, how could you get this without knowing that? Well, one, it's in the notes, but Brian didn't say it today. But we did give a note today also, and I'm sure a lot of people are going to be asking this. We did give a note today right here. And so it's like this little thing that we mentioned for like 1 minute, that the support for something is its confidence divided by its lift. So we need to look for something where low is on the right-hand side, and we need to take the confidence for that rule and divide by its lift and unlift it. So we'd go here to the rules. So let's go to inspect the rules. Let's go to inspect the rules. And that's a graphical error. And then we're going to look where low is on the side. Here's low over here. I'm just going to take this and put this right here. Did it wrap the screen? It didn't. Okay, so we want to divide. We want to unlift its confidence. So we're going to take its confidence right here, which is this, I believe. Double checking. That's its confidence. And we're going to divide its confidence by its lift. So we divide its confidence by its lift, and this is unlifting it. This is going to get us the original support for the thing on the left-hand side. And look, we could have just taken right here. We could take its confidence and divide by its lift. And so it was this one right here, and we divide by its lift. Now, interestingly enough, we should get the same result for all these equations. We're going to cross our fingers, of course, because we always do. And so we get that, and we get that. And then we look at the item frequency again. And you notice it's this. So we've done a lot of confirmation right here, but you can find the original support of an item with the following. To find the original support, it has to be on the right-hand side. Let's put a big note right here. So it has to be on the right-hand side. So whatever's on the right-hand side, you can find the original support for. So the support for the right-hand side is the confidence divided by the lift. And there's an easier way, though, to just look at the item frequency, which tells you the support for each of the individual items. So if you notice here, I went to rules. I found the confidence for the rule divided by the lift. I found the confidence for the rule divided by the lift. And these have different confidences and lifts because they're different rules. Like one was related to how does like merch change impact low and how does high impact low. So you could take, as long as low is on the right-hand side, we can find the support for low. Does that make sense, Vedrana? So let's see if it makes sense. We will see. And then we have another one. We had, where was it? I think Jordan asked one. Was it Jordan asked? Let's see. Where? There it is. Yeah, but doesn't that give us the frequency of how many times low is there? Oh, yeah. I thought the question was asking how many times it's missing. No, and that's the interesting thing. It's a little bit confusing. The way it works with this market basket analysis for now is things are in the basket if they're missing. I know it's like a frequency of things, but this might as well be called like item frequency and then of missingness. So the item frequency it's checking to see how often things are missing, like how frequently is things missing. And low is missing from the data set this many times. It's a little bit confusing. And later on, when we do it for actual market basket analysis, it'll actually be that people are purchasing that item, which will cause a lot of confusion. Like when we get to market basket analysis, people will say like milk is missing from someone's cart 20% of the time, but it's like, no, now we're saying milk is present. So what are we saying right here? Missingness is present in the data set this percent of time for this variable. So it's the idea of like the frequency of missingness, and that will cause confusion. So you are ahead of the game if you're hearing this like hurdle people will have in understanding that it's the item frequency of how often it's missing. So the frequency of missingness. So we're just looking and saying, how often is missingness in this vector? And then we're analyzing the missingness pattern of it to say, well, how does missingness in this impact missingness in this? Does that make sense there? How's that looking? Then we'll do some, I think was it 5C? I thought I saw it. Where? I lost it. Awesome. And, yep, got it. 5E, 5E, let's do it. 5E, 5E, 5E. Left arrow the contents of stock column in buy to a vector called Amazon. Oh, we got this. How do we do this first part? Like once you hear that, just do that first part. We're gonna crush this. We got this question. You can put this, I'll be typing this in so you can put it in the chat. Yeah, I'm copying Jordan. I'm copy pasting your answer. Oh, it's gonna do that period thing, right? Done. First part is done. Make is make sure or something that the levels of Amazon are yes, no, where yes refers to levels in, low, slow, and no. And no refers to everything but those levels. Cool. Oh, that's what I think you're asking about this because you're like, how do I do not those levels? I used to do it other ways. So we can do this a lot quicker now because I've done these questions multiple times and we make small changes and everything. But this one right here, what you're saying is with Amazon, you can see what these things are and you could look at the levels of this. And you look at the levels of Amazon, we have this right here. So what we want to do is we want to rewrite the levels vector. And so left arrow the contents make it so that the levels of Amazon are yes and no, where yes is these things. So let's go right here and let's go to levels of Amazon that are contained in the vector this. Whoa. And then let's get the positions of those. Actually, we might be able to just use it as that. I should do that. I should try it. So if we want to get the positions of these would be, we could call these yes, and we could get the positions of these right here. And those are our yes positions. And then we could go here, and we could get our no positions. And then our no positions are just going to be the flip of the logical. So I'm going to take my logical, and I'm going to flip it, and we should get the no positions. There's the no positions. Yeah, paste your code too. Let me see what you did. Because this is done. This is basically done right here. If anyone can see the rest of it, we're just like one step away. We've got the positions. Now we just need to overwrite those positions. I bet, yeah, yours is looking pretty good too. Yeah, it's looking pretty accurate. It might work. I think what you have works. Where did I lose it to? Yeah, this looks, and I'll tell you what I did different and you did different. You just did it on multiple lines. Yeah, look at, and then you did the flip. Yep, the flip flip is just so nice. You don't have to type of the rest. You're just like, okay, these are these, and then other things are those. The flip is a huge trick because it's like, why type it all out when you can just say like, it is this or it is not this. Awesome job. Yep, I like that. I like that people have to type it out. Mom texting. And so I think you did it. Yeah, because all my code is going to do is just take yours and connect it. So if you look at this, all my code is going to do is go here and go to the yes positions and go here and go to the no positions and store into this yes and store into this no. And we'll run my code now. And then we'll look at the levels of Amazon. And uh-oh. What happened here? Out and unknown. Wait. Let me look at it again. I broke it. Let me look at the levels of Amazon. 1, 2, 3, 4, 5, 6, 7. Yeah, that's right. Okay, it's got them all. Levels of Amazon. Oh, wow. I shouldn't do that. Oh my gosh. I did the wrong thing. This is bad idea. This Dr. Petrie, don't tell Dr. Petrie. Don't tell Dr. Petrie because we need the logical check going on inside of here. When I overwrote yes, it changed them. And then your code's shorter than mine, so I think you just didn't use the which is fine. I think the which is unneeded. So the reason my code broke, which I should have realized it, is because, and I did it the wrong way. Now my code will work. Now the code will work. Because I changed the names of the It's not my day. What is going on? Let me look at this. I wrote too much code. 2, 3, and 5 will be changed to yes. So levels of Amazon are going to change to yes. Let me look at the levels of Amazon again here. Okay, so those will change to yes. Now let me look at the levels of Amazon. Okay, good. Those changed to yes. That's good. And now, oh, you know what? I think I see the issue. The issue is going to be this, is we should do this. We should go here and do that. So now anything that is not yes should be no. So it's just, there's other ways to probably write it. I could probably try to write it another way, but just look at what we're at now. And that's why, yeah, I know, right? That's it. Because now we should get, because those things no longer existed. And now, there it goes. Yeah, that was what it was. So you write a code and you just get the theory down wrong. What you could do is, with the way we wrote it right here, let me go back in time. That's the answer. If you're watching right now, that is the answer. So let me do this. If it's like, we just need to create like a vector. If else, if yes equals. This is way too much work to do this way. If anyone has another question, the way you'd have to do this way, to recode the vector this way, you could do it manually, but you usually want to code stuff. Like I could recode, like what I'm saying is, let me just look at the numbers. I could recode, don't do it this way. This is not the right way to do coding. I could recode no, and then yes, no, and then, see, you're going to make a mistake when you do this. Like, I'm already like, I'm going to make a mistake. And then no. Oh, no, I already have another no. This is the 5th. Yes. Great job, Jordan. Excellent work. No. And then no. Now, this vector right here could be called new names. And then you could literally just go here and you could go to the Amazon vector level and do this. Don't do this. So you could go, and you don't even need this code anymore. This is the right answer down here. Don't do this. Like, put it around the thing. Don't do that. Okay. So this should work. Oh, wait, I lost my new names. Oh, wait, I can grab it here. This is very bad, like, structured code. But that should work. Yeah, that worked. And then this is what you actually want to do down here at the bottom. You want to do this. And this will work also. I mean, it's the way we want to do it. And then that. Yeah. So in the top way, you have to manually do it. In the bottom way, if you get a new data set here, and no matter what the structure is, because you're literally saying, okay, these are the names we want for yes, and then everything else is going to be no. Like if it's not yes, it's no. So, and there's other ways. Since it was one thing, we could have done it. Like this code could have changed right here to the following. This would work also. Knowing like synonymous code and how it works, like when you can, that's no longer a vector. So this will work too. We can check, make sure it works. And that should also work when we run it. You see that works also. So if Jordan, if Chill's checking it out, there's some like just little changes you can make. Since we're only checking one thing, we don't need to worry about the percent and percent. But it's not a bad thing to do percent and percent. I mean, I kind of did it by default too. It just sees if that's contained over there. But if we're doing a logical check with like equals equals, it'll check to see is the first thing equal to this, is the second thing equal to this. But if there was two things over there, it would do is the first thing go to the first, is the second thing go to the second, is the third thing go to the first, is the fourth thing go to the second. It'll permutate across. If you have two things on this right-hand side, it'll like flip-flop. First equals first, second equals second, third equals first, fourth equals second. So if you just have one thing, it works. Percent and percent and equals equals work the same when there's one thing on the right-hand side. But then they change drastically with two things. So if you just want to feel safe being like, is it contained in this? That's fine. Like it's, I mean, same thing. And then I'd say I probably wouldn't have done that in my first few years of coding. I'd be like, I don't know if it's going to do the same thing. And then you run it like 50 times. You're like, okay, that's what it does. More questions, 320, 474 questions. Who's got questions? I've got answers. If you've got questions, I've got answers. Awesome, Jordan. Great work. Great work. I need to check out what's going on in the Discord more often. I need to be like, get on the Discord, check it all out. Check out the Discord. And thank you for everyone who's making the Discord great. I want to see if people are on the Discord. Like, they're on the Discord. Like, he's talking about us now. He's checking out the Discord. Let's hear it here. Okay. BS. Oh, people are talking to the BS 320. I should read this. People are helping out. Oh my God. I should upload the R script from today. Whoa. Hey, wait, let me go. I'm going to say hey to them. What's up, Discord people? Can you guys hear me? Wait. Now I'm muted. I'm still online talking to the Discord channel right now. Just take the headphone out. This is like a phone-in call to the Discord to see if there's any questions. We do a lot of interesting stuff. I think they're AFK away from keyboard. Okay, I'm gonna leave this. I'm gonna leave 320. Yeah, 201 has nothing right now. 201 has no one in it. I just think this is so cool. 474 has no chat. 320 is where the chat's at. People are helping each other out. Yeah, it looks like, wow. Yeah. This is really awesome right here. Really awesome, good help. Man, so cool. I love it. Like people are like, how do I do this? Wait, I figured it out. Yep. Awesome. Man, you guys are awesome. Brian's, gosh. And there's a thing when I post videos. Yesterday, that's so cool. Man. Oh, I guess that's done it. What does the code output? Answer everything except the first row. That's nice. Good job right there. Awesome. I know, that's so cool that he made that. And I think it even says what I uploaded. So, Dennis, like, is really, he say he has some graphic design skills too. I'm like, oh, I gotta talk to you about this stuff, Dennis. Like, I gotta learn more. Then it tells you what the name of the video is. And I changed the name of the videos to try to be more descriptive of what they're about. So you can look at, it won't just say lecture later on. It'll change the name. And hopefully I try to update them as soon as possible so you can use them to review. Dennis is the man. He knows things that I don't know, and I like that. I like it when someone's like, hey, I can do this. I'm like, oh, cool, I can't. Tell me. Do it. That's awesome. and we owe him a huge debt of gratitude because I really see this. I see this as something next semester that we'll be using a lot. So once again, thank you, Dennis, and we'll, let's keep using it. Let's keep staying positive, being awesome, and I think that's got it. I'm probably gonna go eat some lunch. If you have a question, feel free to ask. I think we might end a little bit early today. There's no assignments due right now. We got an assignment due tomorrow night for 474. And then 320's assignment is due on Monday. So they got a lot of time. They're fine. Everyone's fine. Everything's fine. And they'll probably have an assignment due like Wednesday. So there's going to be assignments will start picking up here a little bit. We might go to like every 2.5 days assignments. So get ready. We're about to hit like a burst. We've gotten over the bump of coding. The first assignment's always a big one. And we've done a few assignments like it's our first week and we've done like 2 assignments. This class is like 32 days. So we're doing pretty good pace, but that's got it. Let's head out with some. Should we do Mega Man or Punch Out, Jordan? Mega Man or Punch Out? What's it going to be today to end class? Mega Man or Punch Out? What classic song we're going to play in class to play us out? Oh man, Mega Man's my favorite. Heck yeah. It is end of class, everybody. I will see you tomorrow. Make sure to email me if you got questions. Let's do this. Let's end class.